Yeah, hi everyone, welcome to PrepFusion. So we have seen the basic prerequisites to random variable and now we are going to start the random variable. Okay, so this was the prerequisite that we have seen and now we are going to start the random variable. And in the end of the video, I told you who should be watching the random variables, all the engineering branches, whether you are from EC, electrical, CSE, or even DA guys, or whether you are from mechanical, civil, metallurgy, mining, chemical, all the engineering branches should be watching this video. Okay, because your probability will not end with the probability only. First you need to study probability, then you need to study random variable, then you need to study probability distributions, and then you need to study about stats. So this is how this complete topic will be studied, okay, or complete chapter will be studied. So there are 4 parts of this chapter. So now we are getting started with random variable. So in the end of the video, I gave you important instruction that how we are going to start. So this random variable I have already taught in communication system. This is a core EC subject. So here I have already taught random variables. Now you will be thinking that, sir, this is a subject of EC. So how other students will be able to understand? Now the random variable that I taught here, that was completely mathematical. Okay, completely it was mathematical. It has nothing to do with electronics. So completely mathematical it was, and we have covered right from 0 to advanced. This much content on random variable you are not going to find anywhere. From 0 to advanced, you will see we have covered 1-dimensional random variable, statistical parameters, 2-dimensional random variable, 3-dimensional random variable as well. We have covered central limit theorem, all the kind of distributions, everything we have covered. So right from 0 to everything you will be able to cover. Okay, so let's get started. Let's start studying about random variables. So we will see what is random variable, but before that, let's see some basic terms. So the first term is random experiment. What do you mean by random experiment? So any experiment which is random. What do you mean by random? Random means you don't know the result. You don't know the final result. If I toss a coin, head may also come, tail may also come, right? If I toss a coin, head may also come, tail may also come. So when I am tossing a coin, I don't know what result would come. So this is a random experiment. When you roll a dice, 1 can come, or 2 can come, or 3 can come, 4 can come, 5 can come, 6 can come. But you don't know which of these number will come. So this is also a random experiment. But if you toss a coin which is both sided head, that means you surely know that head only will come. Right? If you toss a coin which is both sided head, that means you know that only head will come. That means it is not a random experiment. So what is the definition of a random experiment? So a setup where you know all possible outcomes, but you can't predict the exact outcome before it happens. So here you know that either head will come or tail will come. Either 1 or 2 or 3 or 4 or 5 or 6 will come, but you don't know what exactly the number would come. So this is the meaning of random experiment. A very simple definition, right? Now what do you mean by sample space? So sample space means set of all possible outcomes. So when you toss a fair coin, what you can get? Either head or tail. So it is the set of all possible outcomes, head and tail, right? Head or tail. When you roll a dice, what you can get? 1, 2, 3, 4, 5, 6. So what is the definition of a sample point? What is the definition of a sample space? Sample space is list of all possible outcome of a random experiment. You did this random experiment. What is the list of all possible outcomes? So 1, 2, 3, 4, 5, 6. When you toss 2 coins simultaneously, so what all possible outcomes you can get? Head you can get, head tail you can get, tail head you can get, and tail you can get. What does this mean? That means on first coin you got head, on second coin you got head. Or it may happen that on first coin you got head, on second coin you got tail. On first coin you got tail, on second coin you got head. On first coin you got tail, on second coin you got tail. So this is the meaning of sample space, that all the possible outcomes have been listed in a set. Possible outcome of what? Possible outcome of a random experiment, right? And what do you mean by sample point? So each element of a sample space is known as sample point. So this is a sample point. Head is a sample point. Tail is a sample point. 1 is a sample point. 2 is a sample point. 3 is a sample point. So each element of a sample space is known as sample point. So this is the definition. Each element of a sample space is known as sample point. Very, very simple thing. Random experiment. You do an experiment where you know all the possible outcomes, but you can't predict the exact result. What do you mean by sample space? Listing out all the possible outcomes of a random experiment. What do you mean by sample point?
each element of a sample space is known as sample point. Very, very simple thing, very straightforward. Now let's go to our chapter, which is random variable. So let's understand the meaning of random variable with example. So what we are saying, x is a random variable. You can understand random and it is a variable. So x is a random variable that represents the number of heads appearing when two coins are tossed simultaneously. So when what you are doing, what is the experiment here? What is the random experiment here? Two coins are tossed simultaneously. So this is your random experiment, right? What x is representing? X is representing number of heads appearing when two coins are tossed simultaneously. This is how you are defining your random variable. Now what is your random experiment? Random experiment is you are tossing two coins simultaneously. That means what will be your sample space? That you can get head, 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 tail, tail, head, tail, tail. Now what random variable x is saying? Random variable x is saying that whatever the outcome that I am getting, I will pick those outcomes. I will pick those outcomes and I will count the number of heads. So let's just say I got head, head. So what this random variable will do? It will pick this head, head and it will count the number of head. What is the number of head? 2. What if I got head, tail? What this random variable will do? It will pick this head, tail. That means it will pick this sample point and it will count the number of heads. What it will count? It will count the number of heads. So how many number of heads are there? 1. It will pick tail, head. How many number of heads are there? 1. It will pick tail, tail. How many number of heads are there? 0. That means this random variable x can take the values 0, 1 or 2. Are you able to understand this point? This random variable can take value 0, 1 or 2 based on the random experiment that you have done. What is the random experiment that you have done? The random experiment is you are tossing two coins simultaneously. If I toss two coins simultaneously, my sample space is head, 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 tail, tail, head, tail, tail. So what this random variable will do, it will take up all the sample points and it will ask them how many number of heads you are having. So this sample point will say I am having 2 heads. This sample point will say I am having 1 head. This sample point will say I am having 1 head and this sample point will say I am having 0 head. So what is the formal definition of a random variable now? So a random variable is a function that assigns a real number to each sample point of a random experiment based on some predefined condition. What is the condition? The condition is the number of heads. So this is the complete definition. You can write it down on your own. A random variable is a function that assigns a real number to each sample point of a random experiment based on some predefined condition. That predefined condition is the number of heads here. Are you able to understand this point? So let's just say my sample space was lambda 1, lambda 2, lambda 3 and so on. So here lambda 1, lambda 2, lambda 3, what these are? These are my sample points. This is a sample point, right? This is also a sample point. This is also a sample point. So all these are sample point. Now what your random variable x will do? Your random variable x will go to this sample point. It will go to this sample point and it will assign a value to this particular sample point. So it went to this particular sample point. And it assigned a value 2 to this particular sample point. So it will assign a value, let's just say 2. Now it will go to another sample point. It will assign it a value. Let's just say it assigned it a value 1. It will go to another sample point. It will assign it a value. Let's just say it assigned the value 1 only. It will go to another sample point. Let's just say lambda 4. It can assign another random value. Let's just say that random value is 0. So x here was taking values 0, 1 or 2. Are you able to understand this point? So these are the values which x was taking. Why I am putting small x? Small x because I am saying that my capital X, which is my random variable, is taking small x values. These small x values are 0, 1 or 2. Okay, that's why I am putting small x here. Are you able to understand this point? This random variable x is taking 0, 1, 2 values, and those values I am calling by small x. So every random variable will take some real values. It could be 0, 0.1, it could be negative as well, it could be positive as well, it could be rational as well, it could be irrational as well. It will take up some real values. A real random variable will take up some real values. We will see more examples, it will become more clear to you. Okay. So as of now, what we are saying, x was a random variable which was representing the number of heads appearing when two coins were tossed simultaneously. So when two coins were tossed, we got the sample space. From that particular sample space, we got the random variable values. Now what if in the question they are asking, find the value of px equals to 0. That means you need to find the probability such that your x is taking the value 0. What do you mean by that? When your x will take the value 0, what they are asking, probability of x taking the value 0. That means if you get telltale only, when your random variable x takes the value 0, when you get telltale only. So if you toss a coin, if you toss two coins simultaneously, what is the probability of getting telltale? That is 1 by 4. That's it. What they are saying, find the probability of a random variable taking the value equals to 0. What does that mean? That means number of heads should be 0. What is x here? X is number of head. So number of heads should be 0. And when you toss two coins simultaneously, what is the probability that number of heads should be 0? That is 1 by 4, because your desired condition is only getting telltale. Let's see the next question. What is the probability of random variable x taking the value 1? What is the probability of random variable x taking the value 1? What does that mean? What is the probability when you toss two coins simultaneously? What is the probability of getting number of heads equals to 1? When you toss two coins simultaneously, what is the probability of getting number of heads equals to 1? That means either you can get head tail or you can get tail head, right? In probability, whenever I say or, that means plus, and whenever I say and, that means multiplication. Okay, or dot I can put. Okay, whenever I say or, that means plus, whenever I say and, that means multiplication. Very basic of probability. I hope you know very basics of probability, right? So what I am saying, the number of heads should be 1 when I toss two coins simultaneously. That means my desired condition would be head tail or tail head, right? So what is the probability of getting head tail? That is 1 by 4. And what is the probability of getting tail head? That is also 1 by 4. So what will be the probability? 1 by 2. Or basically, when you toss two coins simultaneously, what is the probability of getting number of heads equals to 1? Which is head tail tail head. So 2 by 4. That means 1 by 2. What about x equals to 2? What is the meaning of that? What is the probability of random variable x taking the value equals to 2? What is the probability of random variable x taking value equals to 2? What does that mean? What is the probability that when you toss two coins simultaneously, the number of heads should be equals to 2? Number of heads should be equals to 2. So when I toss two coins simultaneously, the number of heads should be equals to 2. That means I want to find the probability of getting head. So out of 4, only one case is there. So 1 by 4. Now px equals to 3. What is the meaning of this? When you toss two coins, what is the meaning of px equals to 3? What is the probability of random variable x taking the value equals to 3? What is the probability of random variable x taking the value equals to 3? What does that mean? When you toss two coins simultaneously, what is the probability that number of head should be equals to 3? I am tossing two coins, but I need number of heads equals to 3. Is it possible? No. So what is the probability? 0. You are tossing 2 coins, but number of head should be 3. Maximum head you can get 2 only, no? And here also you saw that x can take only values 0, 1, 2. That means what will be the probability of x taking the value 3? That would be 0. Are you able to understand this point? Right? What about this one? Probability of a random variable x, probability of mod of x less than equals to 1. Can you solve this inequality? I hope you know how to solve these kind of inequality. You will get minus 1 to 1. In basic mathematics we studied. Okay. Mod of x less than equals to 1. That means x would be between minus 1 to 1. So your x would be between minus 1 to 1. But equal to sign is there. That means you need to find the condition for all the values of x lying between minus 1 to 1. But you know one thing, that x can take value 0, 1 and 2 only. That means what I need to find? I need to find x equals to 0 or x equals to 1. Basically, I need to find the probability. What does this statement say? What is the probability such that random variable x takes the value between minus 1 to 1? What is the probability such that random variable x takes the value between minus 1 to 1? That means random variable x can take value either 0 or 1. It cannot take minus 1 value, which I already know. Look, it can take x equals to minus 1 value, but I know that probability of taking x equals to minus 1 is 0. So why should I write that? Someone will say that, sir, it can take the value x equals to minus 0.333 as well. But you know that you will never get number of heads equals to minus 0.33. It doesn't make any sense. You know that either I will get 0 head or I will get 1 head between minus 1 to 1. Here two condition will not come, because you know that the value of x should be between minus 1 to 1 only. That means 2 will not come. So only these two probability will come. Either you can get x equals to 0 or you can get x equals to 1. Right? Why plus sign came here? Why not multiply? If I say give me a value between minus 1 to 1. So if you give me 0, then also I will be happy. If you give me 1, then also I will be happy. Right? What I am saying, give me a value between minus 1 to 1. So if you give me 0 or if you give me 0 or if you give me 1, in both of the cases I will be happy. That means you don't need to give me 0 and 1. You need to give me 0 or 1. Right? Are you able to understand this point? Why plus came? In case of or, always plus will come. In case of and, always multiplication will come. So if I say my x should be between minus 1 to 1. So either x could be 0 or it could be 1. It could be 0.33. It could be minus 0.33. It could be 0.5. It could be minus 0.5. It could be minus 0.7. It could be plus 0.7. It could be plus 0.8. It could be plus. It could be minus 0.8. It could be plus 0.9. It could be anything between minus 1 to 1, including minus 1 and 1 as well, because there is equals to sign. So that's why or, right? So now you know that what is the probability of random variable x taking the value 0. That means what is the probability such that number of heads are 0, 1 by 4. And what is the probability such that number of heads are 1, that is 1 by 2. So answer is 3 by 4. Is that clear to you? So right now we are just understanding the basic meaning of random variable. I hope it is being clear to you. Well and good. Let's see another example. Y is a random variable that represents the number of heads appearing when 3 coins are tossed simultaneously. So what is the experiment here? 3 coins are tossed simultaneously. So what all outcomes you can get? Head, 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 tail, head, tail, head, head, tail, tail, then tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are the outcomes you can get. Right? I hope how to write down these outcomes. Like 4 times you write down head, then 4 times you write down tail, then 2 times head, 2 times tail, 2 times head, 2 times tail, then head, tail, head, tail, head, tail, head, tail. So in basic 9th class, in standard 9th or standard 10th, we understand all these kind of things, right? Or you might have seen in the engineering as well, or in first year you would have studied all these kind of things, or even in class 11, 12 as well you have studied these kind of things. So these are the possible outcomes. Now what is your random variable x? So what is the random variable y? This time our random variable is y. So our random variable y is number of heads again, number of heads appearing. So what this y will do? It will go to each sample point and it will ask them how many number of heads you are having. 3, right? It will go to this particular sample point. It will ask how many number of heads you are having. It will say 2. Same will be said by head tail head as well, and same will be said by tail head head as well. Are you able to understand this point? If your random variable y is going to head at tail and ask them how many number of heads you are having, it will say 2. If it goes to head tail head, how many number of heads you are having? 2. If it goes to tail head head, how many number of heads you are having? 2, right? Now if it goes to head tail tail, so how many number of heads you are having? 1, right? And same will be said by tail head tail as well, and same will be said by tail tail head as well, right? And now what if it goes to tail tail tail? How many number of heads you are having? 0. So y can take values which are 0, 1, 2, 3. So every time you don't need to write down this step. Our important part would be this particular step. Y belongs to 0, 1, 2, 3. Basically, if I give you this particular statement that y is a random variable that represents the number of heads when 3 coins are tossed simultaneously, and now I ask you, random variable y can take what values? So you will think, okay, if I toss 3 coins simultaneously, if I am tossing 3 coins simultaneously, that means either I can get 0 head, or I can get 1 head, or I can get 2 head, or maximum I can get 3 head. So these values y can take. So every time you don't need to write down this sample space, every time you don't need to go to each element and ask them what is the value you will get. In the mind you can think, no, that if I am tossing 3 coins simultaneously, then the possibility of getting number of heads, either I can get 0 head, or I can get 1 head, or I can get 2 head, or I can get 3 head. Are you able to understand this point, right? And if I want to explain the concept of a random variable here, so what it actually did, although this concept will not be used anywhere, right? What the diagram that I am making here, this will not be used anywhere. What it is doing is that it is going to each particular element, right? It is going to each particular element, more elements are there, and it is mapping these elements on a real value. So this head has been mapped to 3. This head tail have been mapped to 2. This head tail head is also mapped to 2. This head tail have been mapped to 1, and there would be tail as well, right? This tail would be mapped to 0. More points are there, right? More sample points are there. They are also mapped on 0, either on 0 or on 1 or on 2 or on 3. So y can take values 0 or 1 or 2 or 3. Is that clear to you? Okay. Now if I ask you this kind of question, that what is the probability of getting y less than equals to 3? That means what is the probability that y takes the value less than equals to 3? So y can take either 0 or 1 or 2 or 3, right? So what they are asking? What do you think, what will be the answer of this? Without even calculating y equals to 0, without even calculating y equals to 1, without even calculating y equals to 3, and without even calculating y equals to 3, what do you think, what should be the answer? You know that all possible values of y are coming. This random variable either can take 0 or 1 or 2 or 3. So all possible values are coming, no? So this particular answer will be 1, and we can check as well. Probability of getting y equals to 0, that means probability of getting number of heads equals to 0. Which desirable case? Only desirable case will be tail. That means out of 8 cases, only 1 desirable case. Probability of getting 1 head, which desirable case would be there? Head, tail, tail, head, tail, head. So 3 out of 8 cases. What about this one? number of heads should be 2. So head, head, tail, head, tail, head, tail, head, head. So 3 cases out of 8. And what about this? Number of heads should be 3. That should be head, head, head. So 1 case out of 8. What you are getting? 1 only. Now what about this one? You need to solve this inequality. Y square plus 2 less than equals to 6. That means y square should be less than equals to 2. Sorry, y square should be less than equals to 4 because 2 goes here. That means y will be between minus 2 to 2. Do you know how to solve these inequalities? Y square minus 4 should be less than equals to 0. So y plus 2, y minus 2 should be less than equals to 0. Wavy curve method, right? In basics of mathematics, you might have studied it. Right? So this will be plus, minus, plus. So this will be the desirable condition between minus 2 to 2. Very basics of mathematics. Mathematical foundation. In mathematical foundation, you would have studied all these kind of topics, right? So y should take the values between minus 2 to 2. That means I know that y cannot take the value negative. In our case, y can take only values 0, 1, 2. So what will be the desirable cases? Y is taking 0, y is taking 1, and or y is taking 2. These are the desirable case. 0 or 1 or 2, right? So 1 by 8 plus 3 by 8 plus 3 by 8. What is the answer? 7 by 8. This is the answer. Okay, well and good. Next question, you roll a pair dice. Random variable x is number appearing on the dice. Random variable x is defined as number appearing on the dice square minus 6. Are you able to understand what they are saying? When you roll a dice, what will be your sample space? You can get 1, 2, 3, 4, 5, 6. So what is your random variable x? It will take the number that is appearing on the dice, it will do its square and then minus 6. So what all values your random variable x can take? Think about it. Whatever the number that is appearing, do the square minus 6. So 1 square minus 6. If number appearing is 2, 2 square minus 6. If number appearing is 3, 3 square minus 6. If number appearing is 4, 4 square minus 6. If number appearing is 5, 5 square minus 6. 6 square minus 6. So these are the values your random variable x can take. So random variable x can take 1 minus 5, minus 2, 3, 10, 25 minus 6 will be 19 and 30. So your random variable x can take these values: minus 5, minus 2, 3, 10, 19 and 30. Is that clear to you? What is your random variable x is doing? Whatever the number that is appearing, doing its square minus 6. So these are all the possible values that your random variable x can take. Is that clear to you? Now what they are asking you to find? X square plus 2 minus 10 should be greater than 0. So can you solve this inequality? I am solving this inequality here. Okay, because we don't have space left. So x square plus 4 divided by 2 minus 10 should be greater than 0. So can I do this thing? 10 goes here. So x square plus 4 should be greater than 20. So x square should be greater than 16. That means x should be greater than 4 or x should be less than minus 4. Is that clear to you? Again, same thing will happen here. You will get 2 poles, minus 4 plus 4. So plus minus plus. You need the condition greater than, that means this desirable condition and this desirable condition. That means either your x should be greater than 4 or your x should be less than minus 4. Okay. So what they are asking you? Here they are asking you probability of x greater than 4 or x less than minus 4. 4 should not be included, minus 4 should not be included. Now you know that my random variable x can take these values. So what will be the desirable condition? X should be greater than 4. Let's talk about this one. X should be greater than 4. So is it greater than 4? No. Is it greater than 4? No. Is it greater than 4? No. Is it greater than 4? 10 is greater than 4? Yes. 19 is greater than 4? Yes. 30 is greater than 4? Yes. So probability of X getting 10, 19 or 30, right? Basically your X should be either greater than 4 or less than minus 4. That means it can take the value either 10 or 19 or 30. And next they are saying X less than minus 4, less than minus 4, less than minus 4. Minus 2 is less than minus 4? No. 3 is less than minus 4? No. 10 is less than minus 4? No. Less than minus 4, only this condition. That means probability of X getting value minus 5. Are you able to understand this point? Right? Now let's write down the probability. Probability of X getting the value 10. So when your X will get the value 10, your X will get the value 10 corresponding to this particular thing. What I am saying, probability of your random variable X taking the value 10. So when your random variable X will take value 10, when the number appearing on the dice is 4. Is that clear to you? When the number appearing on the dice is 4, then your random variable X will take the value 10. That means when your number appearing on the dice is 4, what is the probability of number appearing on the dice equals to 4? That is 1 by 6. Are you able to understand this point? Basically, here what I am saying is that probability of X taking the value 10 is equals to probability of number on the dice is 4. Say yes or no? Because if the number on the dice is 4, then 4 square minus 6, then you are getting X equals to 10. So X equals to 10 corresponds to number on the dice equals to 4. Are you able to understand this point? And what is the probability of getting 4 when you roll a dice one time? When you roll a dice, what is the probability of getting a 4? That is 1 by 6. X equals to 19. X equals to 19 corresponds to this one. That means the number on the dice should be 5. And what is the probability of getting number 5 on the dice? That is 1 by 6. Probability of X getting 30. Probability of X getting 30 corresponds to the number on the dice should be 6. And what is the probability of getting number 6 on the dice? 1 by 6. X equals to minus 5. X equals to minus 5 corresponds to number on the dice should be 1. What is the probability of getting number 1 on the dice? That is also 1 by 6. So what is the answer you are getting? 4 by 6, that is equals to 2 by 3. So now the concept of random variable is being clear. You can define the random variable in any manner. I did an experiment. I got some sample space. Now I can define the random variable in any manner. I defined the random variable. Previously I was defining as number of heads, right? Number of heads here, number of heads here, or number of tails. But now I defined whatever the number you are getting on the dice, do the square minus 6. So now your X can take values minus 5, minus 2, 3, 10, 19, 30. Then I asked you the probability in inequality. So you should know how to solve the inequality. You got the condition that X could be greater than 4 or it could be less than minus 4. Now X could be greater than 4, that means X should be taking the values 10, 19, 30. Less than minus 4, that means it should be taking value minus 5. Right? Now X equals to 10 correspond to getting number 4 on the dice. What is the probability of getting number 4 on the dice? That is 1 by 6. What is the probability of getting number X equals to 19? What does that mean? It corresponds to getting number 5 on the dice. Right? So in the same manner we got the probabilities and we got the final answer, that is 2 by 3. Is that clear to you or not? This is the final answer. Now the concept of random variable is being clear to you. Say yes or no. Now till this point you can see that your random variable X was taking minus 5, minus 2, 3, 10, 19, 30 value. Here it was taking 0, 1, 2, 3 value. Here it was taking 0, 1, 2 value. So these values were discrete. What is the meaning of discrete? Discrete means 0. Then directly I am taking 1 by 2. So in between 0 to 1 by 2 no number is there, right? Then directly I am taking 2. In between 1 by 2 to 2 there is no number. then directly I am taking 3.5, then directly I am taking 4, directly I am taking 5, directly I am taking 6. That means these values are discrete: 0, 1 by 2, 2, 3.5. There is a jump from 0 to 1 by 2, 1 by 2 to 2, 2 to 3.5. In between 2 to 3.5 there is no number, right? This is the meaning of discrete. And what is the meaning of continuous? That means you are taking all the values from 0 to 1. So whatever the value from 0 to 1 that is coming, that is known as continuous. 0, 0.001, 0.00001, 0.00001, 0.0002. So infinite values are there between 0 and 1. So this is the meaning of continuous. So till this point, whatever the example we took, those were the example of discrete random variable. What I am saying, till this point, whatever the example that we took, those examples were of discrete random variable because values were discrete here. X equals to 0, x equals to 1, x equals to 2. Here x equals to 0, 1, 2, 3. Values were discrete. Values were minus 5, minus 2, 3, 10, 19, 30. But now what I am saying, this is an example that a group of students typically take 30 minutes to 60 minutes to solve a particular quiz. A random variable x is defined such that it represents the time taken by a randomly selected student to solve the quiz. So what do you think? What values x can take? So you know that this particular group will solve the problem from 30 minutes to 60 minutes. Some guy will be solving the problem in 30 minutes. Some guy may solve the problem in 31 minutes. Some guy may solve the problem in 31.2 minutes. Some guy may solve the problem in 59 minutes. Some guy may solve the problem in 48 minutes. So any value between 30 to 60 they may take, no? Any value. 30.0001 minute also they can take. 30.002 minute also they can take. 41.003 minute they can also take. So any value, x could be any value between 30 to 40. 30 to 40. What is the meaning of this? 30 to 40 including 30 and 40. Do you understand the meaning of this particular presentation? When I represented x like this, 1, 2, 3. That means x could take 1, 2, 3. Curly bracket was there. If I am making this large bracket, that means whatever the values are there between 30 to 40, all the values will come including 30 and 40 as well. But here 30 to 60 is there, no? So random variable x can take any value between 30 to 60. Say yes or no. Okay. Well and good. Now what they are asking? Find the probability such that x equals to 35. So what is this? This is known as continuous random variable. Okay. And what was this? All these things here. This was known as discrete random variable. This was also your discrete random variable. This is also known as discrete random variable. Okay. Right. Now what they are asking? Probability of x equals to 35. What is your x? X is defined such that it represents the time taken by a randomly selected student. So what they are saying? Find the probability such that the time taken by a randomly selected student is 35 minutes. There is a group of students. They are solving the problem between 30 minutes to 60 minutes. It is a very, very important point. Okay. So keep your full concentration. So there is a group of students. They are solving the problem between any 30 minutes to 60 minutes. So how many sample points are there? What do you think? Infinity, no? Are you able to understand this point? They can take any time. You don't know which time they will take. They can take 30 minutes, they can take 30.2 minutes, they can take 30.3 minutes. So in all this time window, you are asking that the student would be solving the problem at exact 35 minutes. The student can take any time between 30 to 60. But what you are saying, that exactly 35 minutes you tell me. If you were asking me that between 34 to 35 minutes, what is the probability? What is the probability that a student will take time between 34 to 35? Then it is considerable that you can find the probability. But if you are asking me the probability at a single point, which is like from infinity points you are choosing one point, isn't it? That means probability at a point would be 0. You are asking me a single point. From infinity point you are asking me to choose one point. Probability will be 0. So in case of continuous random variable, probability at a point is always 0. Here I asked you p of x, let's just say here I ask you p of x equals to 10. So probability at a single point I am asking, which was 1 by 6. Probability at x equals to 19, which was also 1 by 6. So in case of discrete random variable, you can find non-zero probability at a point. But in case of continuous random variable, probability at a point will always be 0, because it's like that you can take any time, and in those infinite time window I am asking you only one particular time, that at 35 minutes you let me know that what is the probability that at 35 minutes student is solving the problem. But student can take any time between 30 to 60 minutes. So it's like between infinite time windows you are asking me one particular time. You could ask me one particular time window, that between 34 to 35 minutes what is the probability that student is solving the problem. That is considerable, that will be non-zero. But if you ask me at a particular point, that would be equal to 0 only. And we will prove that with other theorems as well, like with other examples as well we will prove it. But this is the point which student usually mug up, or they solve by the PDF. We will understand what is the meaning of PDF. They will say that from minus a minus to a plus fx of x dot dx, if it is continuous then it will be equal to 0. So they will just remember it, that probability at a point in case of continuous random variable is 0. But why it is 0? Are you able to understand the meaning? That why probability at a point in case of continuous random variable is 0. Okay, those who don't know about PDF, they don't need to worry. We will study that. We will study right from 0. But as of now, you understood one important point, that is, in case of continuous random variable, the probability at a point is always 0. Because in infinite time window, you are asking me one particular time. Right? So there are two kind of random variables: discrete random variable, continuous random variable, and mixed random variable could also be there. Let's write down the example. What is the meaning of discrete random variable? That it can take any discrete values. -2 it can take, 3 it can take, 4.5 it can take, 6 it can take. Or it may also happen that it is taking infinite number of values. What do you mean by infinite number of values? That it is taking discrete values only. -6, -4.3, 2, 4, 7, 11, and it will keep on taking these values till infinity. 13, 15, 19, 21, 37, 42, 1001, 1 lakh 1, 1 crore 1. It will take these values, but discrete values it is taking, and it will keep on taking these values. So this is also discrete random variable. This is also discrete random variable. DRV. In short form, what we will write down? DRV. Here, what do you mean by continuous random variable? That x is taking values between -20 to 40. X is taking values between -20 to 40, including -20, including 40 as well. X is taking values between -2.5 to 3.5. What is the meaning of this small bracket? That it is taking values between -2.5 to 3.5, including -2.5, but excluding 3.5. It will not take 3.5. Before 3.5, it will take all the values. So between -2.5 to 3.5, including -2.5, excluding 3.5. And what is the meaning of this? That it is taking value from 3 to 3.2. So it is taking all the values between 3 to 3.2, but excluding 3.2 and excluding 3 as well. So this is the meaning of continuous random variable. Now some random variable could be, here this is wrong, this should be capital X, right? Capital X, random variable is defined by capital X. So this should be capital X. Capital X is taking values between -20 to 40. Discrete random, mixed random variable could be like this, that X can take value 1 and 2, and sorry, X can take value 1 or 2, or it is taking value from 3 to 6, including 3 and 6 as well. Are you able to understand this point? Between 3 and 6, it is taking all the values, including 3 and 6 as well, and then it is taking two discrete values which are 1 and 2, right? It could be somewhat like this as well, that it is taking two discrete values like -3 and 4, two discrete values it is taking, and it is taking all the values from 6 to 70, including 6, excluding 70. So two discrete value it is taking, and then 6 to 70 all the values it is taking. Is that clear to you? Okay, so this is known as mixed random variable. An important note, the probability at a point is 0 in case of a continuous random variable. In case of continuous random variable, if I ask you probability at a point x equals to a, that will always be equals to 0 in case of a continuous random variable. This is very important, only in case of continuous random variable, because it's like from infinite point you are choosing one point. Is that clear to you? Okay. Now we need to study about probability mass function. So I will take a break, then we will study about probability mass function. You also can take some break if you want to drink some water. So I will drink the water and then I will come back. We will study about probability mass function. Okay. Yeah, welcome back. So now we need to study about probability mass function, PMF. So it is a function only, probability mass function. So it is a kind of function. If I say define a function of x, so how will you define it? Fx. If I say define a function of y, how will you define it? Gy or hy. In any manner you can define the function, right? So it is also a function which defines probability at a point. Probability at a point. So you already know everything about PMF. You already know everything about PMF. So what is the meaning of this particular thing is that this is how it will be written. Small p, capital X, small x. What is the meaning of this? It tells the probability of random variable x taking the value small x. Px small x. This is the notation of PMF. This is how PMF is represented. This is the notation of PMF. Small p, capital X, small x. It tells the probability of random variable x taking the value small x. What is the meaning? Let's just say in place of small x I am putting 10. So Px of 10. What is the meaning of that? Probability of random variable x taking value 10. That's it. So this is the meaning of PMF. Let's see an example. When you toss a coin, when you toss 3 coins simultaneously, your random variable x is number of heads. You already know what all values x will take because these examples we have already seen, right? So x will take number of head could be 0, 1, 2, 3, right? Now you need to find PMF of a random variable x. You need to find the PMF. So what does PMF do? It tells the probability at a point. Tells the probability at a point. That means it will tell probability of random variable x taking value 0. What was that? 1 by 8. Right? All these things we have already seen, right? What is the probability that number of heads will be 0? 1 by 8. What is the probability that random variable x will take the value 1? What is the probability that number of heads will be 1? 3 by 8. What is the probability that number of heads will be 2? 3 by 8. And what is the probability that number of heads will be 3? That will be 1 by 8. So this would be the PMF. This is nothing but the PMF. So whatever the value your random variable x can take, whatever the value your random variable x can take, it will write down all the values and it will write down its probability. X will take 0, x will take 1, x will take 2, x will take 3. So this is how I can make a table that capital X can take the small values of x which are 0, 1, 2, 3. Their probabilities are started with 0, 1 by 8. Their probabilities are 1 by 8, 3 by 8, 3 by 8, 1 by 8. Okay, and I can draw the graph as well. Px of x versus x. When x value was 0, your probability was 1 by 8. When x value was 1, your probability was 3 by 8. When x value was 2, your probability was 3 by 8. And when x value was 3, your probability was 1 by 8. 1 by 8. This particular thing is 3 by 8. So 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So this is how you can make the graph as well. So this is nothing but PMF. So PMF you already knew. This is just a new term. So in the question, if there is mentioned that this is the PMF of random variable x, that means you would understand that it will define the probability at a point. So if this particular graph is given, what will you understand from this particular graph? That probability of random variable x taking the value 0 is 1 by 8. Probability of random variable x taking the value 1 is 3 by 8. X equals to 2, probability is 3 by 8. X equals to 3, probability is 1 by 8. So you should know how to read the graph. Now here this was a discrete random variable, right? So you just let me know for CRV, for continuous random variable, probability at a point is 0, right? What I mean to say is that for continuous random variable, probability at any point is 0 only. That means for continuous random variable, you cannot define the PMF. And if you define, that means at all the point, PMF would be 0 only. Are you able to understand this point? What I mean to say is that for continuous random variable, PMF will always be 0. What is your PMF? Probability at a point such that your random variable capital X is taking capital X. Your random variable capital X is taking small value x. So probability at a point is 0 for any continuous random variable. That means this PMF is only defined for discrete random variable. For continuous random variable, you define something else. What do you define? That we will see. But this particular PMF concept will be only defined for discrete random variable. For continuous random variable, we will define PDF. That we will see later on. But as of now, this is the point which you can mention. Okay, very simple point, very simple definition. Let's go to the next one. So let's see a basic mathematics problem. So as of now, forget about random variable, random process, just a basic mathematics question we are going to see. You need to discuss the concept of continuity at x equals to 1, 2, 3, 5. I hope you know what is the meaning of continuity. What is the meaning of continuity? If I need to check continuity at x equals to a, what I will do? I will check the value at a plus, I will check the value at a, I will check the value at a minus. What is the meaning of a? That means a could be any value. Let's just say it is 3. What is the meaning of a plus? A plus means just ahead of a. Just ahead of a. And what is the meaning of a minus? Just behind of a. Right? So let's check the continuity at all these points. So at x equals to 1. At x equals to 1. If I ask you, if I give you this graph and I ask you what is the value of G1, that means what is the value at x equals to 1? You will say, sir, it is not defined. In signal system, I told you that if there is a sudden jump, you cannot define the value. But in the question, what is given? That G of 1 is equals to 1. What I mean to say is that if this particular thing is not mentioned, and I ask you directly that what is the value of G of 1, that means at x equals to 1, what is the value you are getting? You will say, sir, I cannot define it. Because there is a sudden jump, no? But in the question, they are saying that G of 1 is 1. That means you actually need to consider the next value. So G of 1 is 1, that is given. Now let's talk about G of 1 plus. What is G of 1 plus? Just ahead of 1. What is the value you are getting? 1 only. So G of 1 plus is equals to 1. And what is the value of G of 1 minus? Just below 1. What is the value you are getting? 0. So here what do you see is that G of 1 is equals to G of 1 plus, but that is not equals to G of 1 minus. That means it is not continuous at x equals to 1. Are you able to understand this point? So your graph is not continuous at x equals to 1. Let's check at x equals to 2, 3, 5. Everywhere we need to check, right? We don't have much of space. So what we can do is that we can put all these upward. Let's check at 2 now. So if I ask you, if I directly give you this graph and this information is not given, if I ask you what is the value at x equals to 2, you will say, sir, not defined, because there is a sudden jump. So value is not defined, but in the information that is given that G of 2 is actually 2. G of 2 is 2. What is the value of G of 2 plus? Just ahead of 2, that is 2. And what is the value of G of 2 minus? Just below 2, that is 1. Again, not continuous at x equals to 2, right? Let's check at 3. What is the value at 3? There is no sudden jump. So value is simply 2 only. Value is G3 is simply 2. What is G3 plus? Just ahead of 3. That is also 2. And what is G3 minus? Just below 3. That is also 2. So yes, it is continuous at x equals to 3, right? At x equals to 5, let's check. There is no sudden jump, so at x equals to 5 the value is 3. At 5 plus also the value is 3. At 5 minus also the value is 3. So it is continuous at x equals to 5. So this is the concept of continuity which I just wanted to revise. But one more point I would like to tell. Here what do you see? Although it is not continuous at x equals to 1, right? At x equals to 1, the graph is not continuous. But here you can see that it is continuous from the right hand side. Basically, g of 1 is equals to g of 1 plus. That means I can say that it is continuous from the right hand side. If your g of 1 was equals to g of 1 minus, I would say that it is continuous from the left hand side. This is purely continuous. This is also purely continuous. This is purely continuous. This is also purely continuous. But this is not continuous. But in mathematics, just for the theory purpose, they can say that it is continuous from right hand side, because g of 1 plus is equals to g of 1. G of 1 plus is equals to g of 1. So it is continuous from the right hand side. So this terminology can be used somewhere in your notes or in your some textbook. You will find that this particular graph is continuous from the right hand side. So you should know what is the meaning of continuous from right hand side. What is the meaning of continuous from right hand side? That means g of a plus is equals to g of a. So the point is, if g of a plus is equals to g of a is equals to g of a minus, if this is the condition, that means it is continuous at x equals to a. If this is the condition, that g of a plus is equals to g of a and not equals to g of a minus, that means it is continuous from right hand side. Okay, and if this is the condition that these are not equal but these guys are equal, so the meaning is continuous from left hand side. If nothing is equal, then not continuous at all. Although this is also known as not continuous, but in some mathematics, in some books, you can find that continuous from right hand side, continuous from left hand side. So you should be knowing the meaning of all these three. Is that clear to you? So this is just some mathematics that we wanted to discuss. Now we are going to study about cumulative distribution function, CDF. Very, very important. What is the meaning of CDF? What is the meaning of CDF? Not CDS. What is the meaning of CDF? So what was your PMF doing? PMF was telling probability at a point. Now cumulative distribution function, this is also a function which is represented by capital F. Here you write down capital X and inside you write down small x. So it tells the probability of a random variable x taking values lesser than or equals to small x. This is what it tells. Are you able to understand this point? Let's just say I write down fx of 2. What is the meaning of this? Probability of random variable x taking values less than or equals to 2. So this is what your cumulative distribution function tells. What was your PMF? You remember PMF? Probability of a random variable x taking value equals to x. Probability of random variable x taking value equal to small x. But your CDF will tell probability of random variable x taking value lesser than or equals to small x. Is that clear to you? Let's see a question. With respect to question, it will be more clear to you. Number of heads appearing when 3 coins are tossed simultaneously. The same example we are taking. You need to draw the CDF of random variable x. So what all values x can take? So let's find something very random. Let's find fx of minus 1. Can you let me know what will be the value of fx of minus 1? So what does it mean? Probability of random variable x taking values lesser than equals to minus 1. Can it take value lesser than equals to minus 1? No. It can take only value 0, 1, 2, 3. So it can never take value lesser than minus 1. So what will be the probability? 0. Let's find another random thing. Let's find fx of minus 0.5. Again 0, right? Because random variable x cannot take values lesser than minus 0.5. If I ask you fx of 0, what will be the value of fx of 0? Probability of random variable x taking values lesser than or equals to 0. Lesser than or equals to 0. So it cannot take value lesser than 0, but it can take value equals to 0, right? So it will be equals to probability of random variable x taking value 0, that is equals to 1 by 8. So what do you get to know here? That fx of 0 is coming out to be 1 by 8 for the first time. Let's find out fx of 0.5. What that would be? Probability of random variable x taking values lesser than equals to 0.5. So x should be less than equals to 0.5. What does that mean? That means x can be 0 only, right? So probability of x taking value 0. Again we are discussing discrete random variable only. A lot of example on continuous random variable will also come. So have some patience. So that would be equals to again 1 by 8. So till what point it will remain 1 by 8? You let me know. Look, if your x was less than 0, the probability was 0 only, right? Don't care about that. When it became equals to 0, it became equals to 1 by 8. When it was 0.5, again it is 1 by 8 only, because value of x taking less than or equals to 0.5 would be equals to x equals to 0 only, right? Because it cannot take 0.4, it cannot take 0.3. Directly it can take x equals to 0 only. So till what point it will remain 1 by 8 only? Till x equals to 1, right? Because if I find fx of 1, what does that mean? Probability of random variable x taking value lesser than or equals to 1. X taking value lesser than equals to 1. That means it can take 0 as well, it can take 1 as well, right? It can take 0 as well, it can take 1 as well. So 1 by 8 plus 3 by 8, that would be equals to 1 by 2. This is 1 by 8, this is 3 by 8. 1 by 8 plus 3 by 8 would be 1 by 2. If I ask you fx of 1.5, what that would be? Probability of random variable x taking values lesser than or equals to 1.5, right? So x can take 0 or it can take 1, right? Fx of 2, probability of random variable x taking values lesser than or equals to 2. That means probability of random variable x taking value 0, taking value 1 and taking value 2. What that would be equals to? This is 1 by 8, this is 3 by 8 and this is 3 by 8, right? 7 by 8. If I ask fx of 2.5, so probability of random variable x taking value lesser than equals to 2.5. So it cannot take 2.4, it cannot take 2.3, it cannot take 2.2222, it cannot take 2.3333. All these values it cannot take, it can only take 0, 1, 2. So again the answer would be 7 by 8. And what would be fx of 3? So probability of random variable x taking values lesser than equals to 3. That means 3 will also be included now, right? 1, and you let me know what will be the answer of this particular thing. That will be 1 only. If I ask you what will be fx of 4 for this particular question, if I ask you what will be fx of 4, so probability of random variable x taking values lesser than equals to 4. So it can take 0 as well, it can take 2 as well, it can take 3 as well. 0, 1, 2, 3, everything it can take. That means again the probability will be 1. Fx of 5 will be 1. Fx of 10 to the power 6, probability of random variable x taking value lesser than equals to 10 to the power 6. What that would be? 10 to the power 6. From 0 is lesser than 10 to the power 6, 1 is lesser than 10 to the power 6, 2 is lesser than 10 to the power 6 and 3 is lesser than 10 to the power 6. That means it will always be 1. So starting with 0, it goes till 1. So what kind of graph we are getting? Initially 0, 0, 0 only. Suddenly at 0 you get 1 by 8. So let's draw the graph, right? Let's draw the graph. So it was 0, 0, 0 only. Just 1 second, guys. Yeah, it was 0, 0 only, and at 0 only suddenly it became 1 by 8. So here it became 1 by 8. But if I draw the graph like this, if I draw the graph like this, and if I ask you what is the value of fx at 0, will you say, sir, 1 by 8? If I ask you this question in mathematics, that, sir, what is the value of fx, what is the value of this fx at x equals to 0? What you will say? Sir, it is not defined, right? But even in the examination, in a lot of textbook, in the test series, in the class notes, everywhere you will see that graph is drawn like this. I will also draw the graph in the same manner, but you should know here, what you should know, that fx of 0 is actually equals to fx of 0 plus. If I ask you fx of 0, then you should think, okay, at a point you are asking, that means I need to look ahead. If there is a sudden jump, I need to look ahead only. Are you able to understand this point? Ideally, graph should not be made like this. Are you able to understand this point? This line should not be there, right? Why this line should be there? This green line should not be there. This particular green line should not be there. Because if I make this green line, that means I am telling that there is a sudden jump at x equals to 0. And if there is a sudden jump at x equals to 0, that means I cannot define the value at x equals to 0. But actually it is defined, because here we saw that fx of 0 is actually coming out to be 1 by 8. It is not undefined. It is actually coming out to be 1 by 8. So although we will make the graph like this, although in the examination as well the graph will be made like this, but since it is CDF, so since it is the graph of CDF, so in the CDF you should know that if I am talking about probability, if I am talking about the value at a point, if I am talking about value at a point, that means I am talking a plus. If I am talking the value at a, that means I am talking about a plus. So in case of CDF, fx of a plus will always be equals to fx of a. It might not be equals to fx of a minus, but this will always be there. Is that clear to you? Okay, fine. Yeah, so 1 by 8. Then at 1 what was happening? Till 1 it was remaining there only, like 0.5 was also giving 1 by 8. Then fx of 1 was giving 1 by 2. So from 1 by 8 you made a jump to 1 by 2, right? Then when you got the value 2, then again you made the jump to 7 by 8. So it was there 1 by 2, 1 by 2 only. When x became 2, when this small x became 2, when this capital X took the value 2, then it became 7 by 8. Then it became 7 by 8. And then when x took the value 3, it became 1, right? And then it always remained 1. So this kind of graph we are getting. So 1 by 8, 1 by 2, 7 by 8, 1 by 2, 7 by 8, and 1. So this kind of graph we were getting. Now if this particular graph is given you, let me know all these things. First thing is this, you need to remember this particular thing. Although this graph is not correct, but everywhere in the test series, in the textbook, in the examination as well, this kind of graph will be made. So you should know one particular thing, that if I am asking you the value, let's just say if I am asking you the value at x equals to 2, then you should not be saying that the value is undefined. No, you should be knowing that the value is actually, I need to look ahead. So the value actually is 7 by 8, right? The value is 7 by 8, right? And this is the value is, this value is there at x equals to 1. So this is how you need to remember. And at x equals to 3, this is the value. So CDF doesn't tell the probability at a point. Probability at a point is told by PMF. CDF will tell that, well, probability of a random variable x taking values lesser than equals to small x. This is what your CDF will tell. Is that clear to you? Okay. So this is the graph of CDF that we are getting. Now if I randomly ask you from this graph, what is the value of fx of 3? What you will say? Sir, as per the graph, it looks like it is not defined, but actually it will be fx of 3 plus, which is actually 1. If I randomly ask you, what is the value of fx of 0? So sir, as per the graph, it looks like it is not defined, but actually I need to look ahead. 1 by 8. If I ask you, what is the value of fx of 1.33? So sir, 1.33 would be somewhere here. The value is actually 1 by 2. Is that clear to you? So this graph we took, this example we took, and there I said that g of 1 actually looks like it is not defined, but it is actually equals to 1. So I was referring to CDF only. Are you able to understand this point? So can I say that CDF is always right continuous? Like if I ask you fx of 1.33, that is 1 by 2. Fx of 1.33 plus, what that would be? That will also be 1 by 2. So fx of 1.33 minus, what is that? That is also 1 by 2. So it is completely continuous at x equals to 1.33. But if I ask you what is the value of fx of 0 and fx of 0 plus, that is 1 by 8. But what is the value of fx of 0 minus? That is equals to 0. So here what did you get to know? That 0 plus is equals to 0, but that is not equals to 0 minus. So it is always continuous from the right. It might not be continuous from the left. It may be continuous from the left, it might not be continuous from the left, but it will surely be continuous from the right. So your cumulative distribution function is always continuous from the right. This kind of statement could be there in true or false. Okay, so that's why I was referring to this particular concept: continuous from the right hand side, continuous from the left hand side. Is that clear to you? Although we will write down all these points later on, but yeah, as of now in the graph you can see this. Okay, all fine. So let's solve this question. So we will solve this question, and from here we will make a very good conclusion. So whatever the conclusion that we are going to make, that is more important. Okay, so let's solve the question. You will not be able to solve on your own. So see the solution and then we will see the conclusion. So probability of random variable x taking values between -1 to 4, including 4, excluding -1. This is what you need to find. Okay, so first question, what we need to find: probability of random variable x taking value between -1 to 4, including 4 and excluding -1. Can I write it down in this manner? So let's make the line first. What do we need? We need, this is our -1, this is our 4. So -1 to 4, including 4 but excluding -1. So this is what we need. We don't need -1, we need 4, right? So can I write it down in this manner? Probability of random variable x taking values lesser than 4. That means all these values it is taking. But we don't want all these values. We don't want these values, right? We only want these values. So what I need to do? Minus probability of random variable x taking values lesser than equals to 1. Is that clear to you? Here equals to will come. Why is that so? Because I don't want values lesser than 1, including the 1 as well. Because I don't want -1, sorry, not 1, -1, really sorry guys. I don't want values lesser than -1. It was -1 only, no? Yeah. I don't want values lesser than -1, including the -1 as well. I don't want -1 as well. I want the values between -1 to 4. Is this clear to you or not? If I want the value between -1 to 4, that means I want values lesser than 4, including the 4, right? But I don't want -1. So can I write it down in this manner? That this is fx of 4 minus fx of -1. Is that clear to you? Can I write it down in this manner? Because what is your fx of x? Fx of x is probability of random variable x taking value lesser than equals to small x. So this is your fx of 4. That means probability of random variable x taking value lesser than equals to 4. And this is your fx of -1. And one thing you already know. What do you know? That in case of CDF, fx of a plus is equals to fx of a. So this can be written in this form as well. Fx of 4 plus minus fx of -1 plus. Is that clear to you? So that plus sign could also be given. So anything could be given. This can also be mentioned in your examination, and this can also be mentioned in your examination. Although you can calculate the value, fx of 4 plus is 7 by 8. Fx of -1 plus that is 2 by 8. So 7 by 8 minus 2 by 8. 7 by 8 minus 2 by 8. What is the answer you are getting? 5 by 8. Okay. Let's see the second one. It is a very, very important concept. Okay. And very good conclusion we are going to make from here. -1 to 4, excluding both of them. -1 to 4, excluding both of them. Right? So what I need to write? Probability of x less than 4. Again, let's draw the graph here. What do I need? I need values between -1 to 4. -1 to 4. I don't want 4, I don't want -1 as well. I want only these values. So can I write it down in this manner? Probability of x less than 4 minus probability of x less than equals to 1. Is that clear to you? Because I don't want 1. I don't want 4, I am not taking 4 here. Values lesser than 4. And here values lesser than 1, excluding 1 as well. Basically, if I am subtracting it, that means values lesser than Again I am writing 1, it is minus 1. Really sorry guys. So values lesser than minus 1, also minus 1 should also be excluded. So I am getting between minus 1 to 4. Is that clear to you? Right? Can I write this down? Can I write this particular thing in this manner? That it is your probability of x less than 4 minus probability of x equals to 4. What I am doing is that probability of x less than 4 I am writing down in this manner. Probability of x less than equals to 4. That means 4 and less than that. That means 4 is included. But actually what I want, x less than 4 only I want. That means 4 should not be included. So what I am doing, x equals to 4. Very simple thing, very basic mathematics. Is that clear to you? You don't need to remember all these things. We will make some conclusion out of it. And from these conclusion, you will be able to solve the problem within 5 seconds. But are you able to understand the concept here, what I am doing? Is that clear to you? Why I am putting this equal sign? Because I need to write down in terms of a CDF. And in CDF, there is equals to sign is also there. That is very important. Equal to sign is very, very important. So if I want this equals to sign, because of that, I need to follow this particular process. Is that clear to you? So what I did, probability of x less than 4, I am putting as x less than equals to 4 minus x equals to 4. Is that clear to you? Right? Minus probability of x taking value less than equals to minus 1. So what is this? Fx of 4. And what is this? Fx of minus 1. And what is this? And you know one thing, fx of 4 is equals to fx of 4 plus fx of minus 1 is equals to fx of minus 1 plus. So most probably this option will be mentioned in your examination. This particular option will be mentioned in your examination. Most probably this particular option will be given. Okay, but we will write down another point. We will see it in another manner. What we will do, let's talk about this particular thing, fx of 4 minus probability of x equals to 4. Let's talk about this particular thing. What this can be equals to. If I ask you, find me fx of 4 minus, what you will do? Probability of random variable x taking values lesser than equals to 4 minus. What does that mean? What is the meaning of 4 minus? Just before 4. Are you able to understand this point? Fx of 4 minus. If this is your 4, if this is your 4, this would be your 4 minus. That means it is telling that probability of random variable x taking values lesser than equals to 4 minus. That means 4 minus is included until minus infinity you can go. Minus infinity to minus 4, everything you can tell. But 4 should not be included. So can this be equals to probability of x less than 4? Are you able to understand this point? Fx of 4 minus is equals to probability of random variable x taking values lesser than equals to 4 minus. And that would be equals to probability of x less than 4. Because 4 minus is just before 4. And what this is telling? From 4 minus to minus infinity, everything you can take. That means you cannot take 4. And this is what you want from this. Is that clear to you? So this is the first way that this is how the option could be mentioned. What could be the other way? From here you write down probability of minus 1 to 4. The other way could be, this particular thing can be written as fx of 4 minus this particular thing could be written as fx of minus 1. This can also be mentioned in your examination. Both should be clear to you. You should have the habit of writing down both. We will see the conclusion. With respect to the conclusion, you will be able to write down very, very, very quickly. Is that clear to you? All good? All fine? Right? Okay. And one thing you already know, that fx of minus 1 will be equals to fx of minus 1 plus. So again, another form I can write down, that would be between minus 1 to 4. Another form I can write down fx of 4 minus fx of minus 1 plus, because I know that fx of a is equals to fx of a plus. So this could also be one of the possible form. So 3 forms I have written here. And have patience, in the examination you will not have to follow this process. I will tell you very simple method. By that particular method you will be able to write down the expression, but as of now you should know how we are solving these kind of problems. Between minus 1 to 4, excluding the 4, if 4 was not included, then all these problems, this is how we will write it down. Is that clear to you? All good? Let's see the next one. Let's see probability of x equals to 4 first. What I am asking? Probability of x equals to 4. Let's find out this particular thing. Although what will be the answer of this particular question? Fx of 4 minus, that was 4 by 8. Fx of 4 minus, right? This was your 4 minus, that was 4 by 8. Fx of minus 1 plus, that was 2 by 8. So answer was 2 by 8, that is 1 by 4. Okay. What about this one? Probability at x equals to 4. Probability at x equals to 4. Can I write it down in this manner? You let me know. X less than equals to 4 minus x less than equals to 4 minus. You let me know. Probability, this is 4 and this is 4 minus. X less than equals to 4. That means including the 4, everything. And what is the meaning of x less than equals to 4 minus? Excluding the 4, everything. Basically, probability of x less than equals to 4 minus is equals to probability of x less than 4. Do you agree to this point? Yes, x less than 4 or x less than equals to 4 minus. That means including minus 4, everything. That means excluding 4, everything. Is that clear to you? Is this statement clear to you? Surely it is clear to you. So it could be written as fx of 4 minus fx of 4 minus. Right? Or it could be written as fx of 4 plus, because fx of 4 is equal to fx of 4 plus, fx of 4 minus. So this is your probability at a point. Don't worry about all these things. I will tell you a method as well. By that method you will be able to write down very quickly. So in 2 forms the answer could be mentioned. Although in the examination what they will do, they will ask these forms. They will not give the graph or anything. They will just ask these forms, right? So what will be the answer? 4 plus 4 minus 7 by 8 minus 4 by 8. 7 by 8 minus 4 by 8. The answer would be 3 by 8. Right? Let's see the C question now. Now you should be able to do everything on your own. Let's see the C1. Minus 1 to 4. Minus 1 to 4. So how will you write it down? Probability of x less than 4 minus probability of x less than 1. There you go. Right? Why is that so? Because what do you need? You don't need 4, but you need 1. You don't need 4. That means x less than 4. But you need, again it is minus 1. Again I am doing the same thing. But you need minus 1 as well, right? You need minus 1 as well. That means x less than minus 1 you need. This particular thing you need. Less than minus 1 you need. Is that clear to you? Are you able to understand what I am saying? Less than 4 and less than minus 1. That means minus 1 you need. You need minus 1. Minus 1 has to be there. So less than 4, that means 4 will not be there. And less than minus 1, that means minus 1 will be there. Right? Are you able to understand this point? So what it could be written as? Can I write it down as x less than equals to 4 minus? Say yes or no. Minus probability x less than equals to minus 1 minus. Can I write it down in this manner? X less than equals to 4 minus probability of x taking value less than minus 1 minus. Because here what do we show? Basically the general point is probability of x less than a minus is equals to probability of x less than a. Do you agree to this point? Probability of x less than equals to a minus is equals to probability of x less than a. Do you agree to this point? Surely you agree to this point, right? Less than a less than equals to a minus. That means a minus till minus infinity. From a minus to minus infinity. And what does this say? From a minus to minus infinity only. This is also say the same thing. This is also saying the same thing, right? So what this could be written as? Fx of 4 minus minus fx of minus 1 minus. So this is the first way of writing it down, which probably will not be mentioned in the options. Okay, this might not be mentioned in the options. What could be mentioned in the option? Let's go here again. Okay, so probability of x less than 4. So you know what is probability of x equals to 4. That is probability of x equals to 4 is fx of 4 plus minus fx of 4 minus. So from here fx of 4 minus can be written as fx of 4 plus minus probability of x equals to 4. So yes or no? You know this particular thing already. Probability at x equals to 4 is fx of 4 plus minus fx of 4 minus. So from here fx of 4 minus could be written as fx of 4 plus, and this goes here, minus probability of x equals to 4. So what this could be written as? Fx of 4 minus. Fx of 4 minus could be written as fx of 4 plus fx of 4 plus minus probability x equals to 4, right? Minus. What about this one? Fx of minus 1 minus. Similarly, fx of minus 1 minus could be written as fx of minus 1 plus minus probability of x equals to minus 1. So here what I will write down? Fx of minus 1 plus minus probability of x equals to minus 1. So what you are getting? Fx of 4 plus, which can be written as fx of 4, because you know that fx of 4 plus is equals to this fx of 4 plus is equals to fx of 4 only, because fx of a plus is equals to fx of a. So fx of 4 plus could be written as fx of 4 minus, this can be written as, this minus sign, this can be written as fx of minus 1 minus probability of x equals to 4 plus probability of x equals to minus 1. So this could be mentioned in the option. Like high chances are there that this particular thing will be mentioned. High chances are there that this particular thing would be mentioned in the options. Okay. 4 minus 1, probability at x equals to 4, probability at x equals to minus 1. Now you are able to think, right? What fx of 4 will say? Including the 4, everything. Including the minus 1, everything. So in this particular thing, what do you see? That 4 has been included and minus 1 is not included. In this particular thing, what do you see? That 4 has been included and minus 1 is not included. But what do you want? 4 should not be included. 4 should not be included, but minus 1 should be included. That means you will add up the probability of minus 1, but you will subtract the probability of 4. So you added up the probability of minus 1, you subtracted the probability of 4. Is that clear to you or not? Fx of 4 will say that including the 4, everything. Minus 1 will say that including the minus 1, everything. That means if there is a subtraction sign, that means minus 1 is also gone and rest of the things is also gone. Right? So that means 4 is included, minus 1 is not included. But what do you want? You want that 4 should not be included, but minus 1 should be included. So you will subtract 4, but you will add up minus 1. Is that clear to you? A very good concept we are seeing here. Okay. Let's see the last one. In the last one, what do we want? And surely we will write down the conclusion. It will be just a cakewalk for you. Within 1 second, you will be able to write down everything. Minus 1 to 4. Minus 1 to 4, including the both. Minus 1 to 4, including both. So what do you think? How will you write down? Think about it. If I write down fx of 4, what does that mean? Just 1 second, guys. Just 1 second. One call is coming. Yeah. So what I was saying. So minus 1 to 4, right? So basically, you need 4 as well this time and you need minus 1 as well. You need both of them. You need 4 as well, you need minus 1 as well. So if I am writing fx of 4, what fx of 4 is saying? That it will include 4. So yeah, our job is done. Including the 4, our job is done. Now let's just say if I write down fx of minus 1 here. So what it will do? It will kill minus 1. It will kill minus 1 and rest of all the things. But what do you want? You need minus 1. If I subtract fx of minus 1 here, what is the meaning of fx of minus 1? Fx of minus 1 means probability of x taking value lesser than equals to minus 1. That means it will kill everything including the minus 1 as well. So minus 1 is also gone, but you need minus 1. That means probability of x equals to minus 1 you need to add. There you go. This would be one of the possible options mentioned, right? What could be the other option mentioned? You know that what is your probability of x equals to minus 1. Basically, I need to kill this probability of x equals to minus 1. So I know that it would be equals to fx of minus 1 minus fx of minus 1 minus, right? Or you can say that fx of minus 1 plus, because fx of minus 1 plus is equals to fx of minus 1 only. So this is your probability of x equals to minus 1. So x equals to minus 1 could be replaced with probability of x equals to, yeah. So probability of x equals to minus 1 is this. So in place of 1 plus, let's write down, in place of minus 1 plus, if just write down minus 1, right? So what I will get is that if I do, I am taking this towards this side. So what you will get? Probability of x equals to minus 1 minus fx of minus 1 is equals to minus fx of minus 1 minus, right? So what is this? Probability of x equals to minus 1 minus fx of minus 1. So from here, what do you see? This is fx4 and what this is equals to fx of minus 1 minus, right? And this 4 could be equals to 4 plus as well. So here if I am writing down minus, here I am writing down plus. So this could be the other option mentioned. Is that clear to you? We will surely write down the conclusion now, but the concept is clear to you, know, that how we go to these particular answer. So let's write down the conclusion. What do we need to do? So probability of a random variable x taking values from a to b, including the b, excluding the a. How will you write it down? So always you will remember this condition, that on the lower limit I don't want the equal sign, on the higher limit I want the equal sign. On the lower limit I don't want the equal sign, at higher limit I want the equal sign. If this is the condition, then no problem is there. Directly it will come. There you go. And this could be equals to fx of b plus fx of a plus, right? Because you know that fx of alpha is equals to fx of alpha plus in case of CDF, right? So this condition you will remember, that on the lower limit I don't want the equal sign, on the higher limit I want the equal sign. Here on the lower limit I don't want the equal sign, but at the higher limit I want the equal sign. That is not there. That means there is some problem at the higher point. There is some problem at the higher point. That means you will write it down as fx of b minus minus fx of, on the lower limit I don't want the equal sign and it is not even there. That means I don't have any problem. And that can be written as fx of b minus fx of b minus minus fx of a plus. So here there was no problem, but here there was problem. Because there was a problem, so b minus came. Now in the examination it might happen that they will not give b minus. So what you will do? So now you will think that I know that probability at x equals to b will be equals to fx of b minus fx of b minus, or it can be written as b plus as well, right? It can be written as b or b plus, whatever it can be written. So fx of b minus would be equals to fx of b minus would be equals to fx of b minus probability at x equals to b, right? And this could be written as fx of a only. Okay, so usually in the examination when the question comes, they don't put plus minus here. This kind of option would be mentioned. Neither here plus is there, here also there is no plus. This is simple probability. But here I am putting minus, here I am putting plus. All these plus minus will not be mentioned. If this particular question is coming, then this answer would be mentioned. If this particular question is coming, then this particular answer would be mentioned. Are you able to understand this point? And or you can think as well, no, that if I write down fx of b, that means I am taking everything including the b, but I don't want b because here I don't want b. So what I will do, I will simply subtract the probability, right? Or if you don't want to think, just remember this particular first expression, that b should be included and a should not be included. Here both are having the problem, that on the higher limit I wanted the equal sign, on the lower limit I did not want the equal sign. That means both are having the problem. So what would be the answer? Fx of b minus fx of a minus. But in the examination this might not be mentioned. In the examination what will be mentioned? What is your fx of b minus equals to? It is equals to fx of b minus probability at x equals to b, because fx of b will say everything including the b, but you need to kill the b. Now minus, what is your fx of a minus? Fx of a minus is fx of a minus probability at x equals to a. Since this there will be bracket, so if you open the bracket, this would be equals to plus. Is that clear to you? So this particular option could be mentioned in the examination. This might not be mentioned. There is very high chance that this particular option would come. Fx of b minus fx of a plus px of a minus px of minus b. And you will be able to think, including the b, now b is excluded. Here a is excluded. A is excluded, but because of this a is included now. Is that clear to you? So all this discussion we have done just to understand these particular answer. Now here on the lower limit I am having the problem, but on the higher limit I am not having any problem. On the lower limit I am having the problem, on the higher limit I am not having any problem. So fx of b will come as it is, but on the lower limit there is a problem. So here in place of b I can write down b plus as well. On the lower limit there is a problem, so a minus. This could be written as what? So fx of b plus can be written as fx of b only. Fx of a minus could be written as what? Fx of a minus could be written as fx of a, but you don't want probability at x equals to a. You don't want probability at x equals to a, right? Am I doing it correctly? Fx of b, fx of minus a, yeah. Or forget about it, don't think like that, no. What you will think? Okay, from here I will start thinking. From a to b, including a as well, including b as well. So what I will think? That I need b, okay, yes, I need b. If I subtract fx of a, that means a is also gone and less than a is also gone. But you don't want a to be go. You don't want a to be gone, right? You want a. That means you will have to add probability of x equals to a. And if you don't want to think in this manner, what you will do? You will write down this very easily. This you will be able to write down very easily, right? Fx of b plus minus fx of a minus, very easily you will be able to write down, because on the higher limit there is no problem, on lower limit there is a problem. So this is what you can write down, and then you will think that probability of x equals to a is equals to fx of a minus fx of a minus. So fx of a minus would be equals to fx of a minus would be equals to fx of a minus probability of x equals to a. So from here you will just put fx of a minus from here, right? And that would be equals to minus fx of a plus probability of x equals to a. So this particular answer you will get. So here you are using your brain. If you don't want to use your brain, then direct method also I am telling you. Is that clear to you? And what is the probability at a point? Then probability at a point is actually given as fx of a minus fx of a minus, or it could be written as fx of a plus minus fx of a minus. Is that clear to you? So these expressions are very, very, very important. Okay. Now you know one thing. What do you know? In case of continuous random variable, probability at a point would be equals to 0. Px of a is equals to 0. So you just let me know this particular thing. All these will be equal or not, and they will be equals to fx of b minus fx of a. Why is that so? Because you see this particular expression here, directly this is coming, no issue. You see this particular expression, see here, fx of b this particular thing will be 0 in case of continuous random variable. So what you will be getting? Fx of b minus fx of a. You see this particular expression, this will be 0, this will be 0. What you will be getting? Fx of b minus fx of a. You see this particular expression, this will be 0. What you will be getting? Fx of b minus fx of a. Is that clear to you? So in case of continuous random variable, you don't even need to think of this equal sign or unequal sign. But in case of discrete random variable, you need to think about these equal sign and not equal sign. Is that clear to you or not? So basically in continuous random variable, there will not be any staircase. Here you saw this particular diagram, no? There was a staircase. Here also there was a staircase. So if you see the staircase, that means they are talking about discrete random variable. But if you see a continuous graph like this, that means it will be continuous random variable. Are you able to understand this point? Okay. So if there is a discrete, if there is a staircase like this, that means it is discrete random variable. If there is a continuous graph like this, that means it is continuous random variable. Is that clear to you? Continuous graph, continuous random variable. Staircase like this, that means discrete random variable. Is this clear? Right? So this particular question that we have seen, and this particular conclusion was also very important. So fx of alpha is always equal to fx of alpha plus. Probability at a point is given by fx of b, fx of minus b minus. You need to remember this condition that at lower limit I don't need the equal sign. At higher limit I need the equal sign. Then directly answer will come fx of b minus fx of a. Here lower limit was having the problem. Higher limit was having the problem. Lower limit was not having any problem. So higher limit was having the problem. So fx of b minus came. But usually this particular thing will not be mentioned. Fx of b minus could be replaced from here. Fx of b minus probability of x equals to b. So this is how I can replace it. I can get the answer. Or I can think directly as well, that if I write down fx of b, that means I am taking b into action as well and less than b as well. But I need to kill the probability at x equals to b, so I will subtract it. Then I need to kill the probability at x equals to a as well, then fx of a. So either you can think, which is very easy to think, or you can, if you don't want to think, if you just want to apply some formula or method, then this is how you can apply the formula as well. Is that clear to you? Everything is crystal clear. Every single point is clear to you, right? Because this is very important. I am expecting that question will come from this particular topic, and we have put a problem as well. Right? We will solve a lot of questions. So in those questions, we will solve this kind of problem. Okay? Their options will not be mentioned like this. I have seen that people will mug up these formula, fx of b plus minus fx of a plus fx of b minus fx of a, but they will mug up this particular formula, but they don't even know that this is how the option will be mentioned. So you should care about the options as well, no? Right? So this point is clear to you. Let's go to the next one. You need to see the properties of CDF. So if I ask you fx of infinity, what is the meaning? Probability of random variable x taking values less than equals to infinity. What do you think? What will be the answer of this? 1. Because x will not take value greater than infinity, no. Every value is less than infinity only. So x cannot take value greater than infinity. So probability will be 1. What about fx of minus infinity? Probability of x taking values less than equals to minus infinity. What do you think? What will be the answer? Can x take any value lesser than minus infinity? No. Answer will be 0. So fx of minus infinity is 0, fx of infinity is 1. Let's see these graphs. 0 to 1. Starting with 0 to 1. And always in the non-decreasing manner. The graph is non-decreasing. You cannot say it is increasing. Here the graph increased, then it remained constant, then again increased, then again remained constant, again increased, constant, again increased, constant. But it never decreases. The graph never decreases. So CDF is a non-decreasing function. You cannot say increasing, but you can say non-decreasing function. So CDF is a non-decreasing function. What is the value, minimum value? That is 0. What is the maximum value? 1. So it can never be negative as well, right? Minimum value is 0, maximum value is 1. So from 0 to 1 it will go, because it is representing probability only, no? Although it is representing probability less than or equals to a particular value, but surely it is representing a probability only, and probability will always be between 0 to 1. So CDF will always be between 0 to 1 only. It is a non-decreasing graph. If x2 is greater than x1, that means fx2 would be greater than equals to x1. You see this graph. Let's just say this is my x1 and this is my x2. So you know that x2 is greater than x1. So values are equal here. fx of x2 is equals to fx of x1. Are you able to understand this point? Here, if I say this is my x1, this is my x2. So I can say that fx of x2 is equals to fx of x1, which is equals to 3 by 8. And if I say my x2 is here, where is my x2? My x2 is here. So x2 is greater than x1. x2 is greater than x1 and this value is also greater than this one. Basically, if x2 is greater, then fx of x2 cannot be lesser. It can be equal or it can be greater. Are you able to understand this point? Because graph is non-decreasing, no? Graph will either remain constant or it will increase. It will either remain constant or it will increase. It will never decrease. So if x2 is larger, then the function will also throw either larger value or equal value. Is that clear to you? Very simple point. Okay. And fx of a plus is equals to fx of a. That means continuous from right hand side. And how will you write down this probability, this particular thing? Fx of b minus fx of a, right? So these are the properties of CDF. And this conclusion also should be there in your mind. So this slide and this particular slide is conclusion of whatever that we have studied till now in case of CDF, right? Let's see the questions now. Which of the following CDF is valid? So for CDF, what will happen? The graph will rise up from 0 to 1. It can remain constant but never decrease. Decreasing is not allowed. Decreasing is not allowed. So here graph is decreasing, not allowed. In rest of the cases, it is not decreasing. It will start from 0 and will go to 1. Starting from 0? No. Will go to 1? Yes, it is going to 1. Will go to 1? It is going to 2. Wrong. Now, starting from 0, going to 1. Yes. In a non-decreasing manner? Correct. Starting from 0, going to 1 in a non-decreasing manner. Here it increased, then again increased. So it never decreases. Increased, 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 constant. So this is also correct. So which of the following CDF is valid? So these two CDF are valid, rest or are invalid. Starting from 0 will go to 1. Starting from 0 will go to 1. Going to 2, starting not from 0, starting from 1 by 2. And here it is decreasing, which is also wrong. Here it is going from 0 to 1, but it is decreasing. So what all are the condition? Should go from 0 to 1 in a non-decreasing manner. That's it. Should go from 0 to 1 in a non-decreasing manner. So this is about CDF. Let's see this question. CDF of random variable x is shown. You need to find the probability at x equals to 1, x equals to 2, x equals to minus 2 and then in these ranges. So quickly you let me know the answer. Probability at x equals to 1. What that would be? Fx of 1, or you can write down 1 plus minus fx of 1 minus. So what is the value of fx of 1 plus? Here is 1. 1 plus, 1 plus, the value is 3 by 4. And what is the value at 1 minus? The value is 1 by 2. So what you are getting? 1 by 4. 3 by 4 minus 1 by 2. 1 minus is 1 by 2. 1 plus is 3 by 4. Probability at x equals to 2. So fx of 2 plus fx of 2 minus. Fx of 2 plus, what is the value? 1. Fx of 2 minus, what is the value? 1 only. 2 minus just before 2. 1 only. What is the answer? 0. And you can see that graph is continuous here. Whenever the graph is continuous, the probability at a point would be 0. If the graph is continuous, no? But here at x equals to 1, there was a sudden jump. If there was a sudden jump, then probability at a point would be non-zero. Otherwise, it will be 0 only. Let's see the third example. Probability at x equals to minus 2. So let's see the graph at x equals to minus 2. The graph is continuous. It will be surely 0. You can check fx of minus 2 plus fx of minus 2 minus. Minus 2 plus, what is the value? 1 by 4. Oh, sorry. The graph is not continuous, no? At minus 2, there is a jump. Really sorry. At minus 2, there is a jump, no? Minus 2 minus value is 0. Minus 2 minus value is 0. And minus 2 plus value is 1 by 4. So at minus 2, graph is not continuous. There is a sudden jump. Here also there was a sudden jump. But here there was no jump. If there is a sudden jump, answer will be non-zero. So what do you think this graph will be made for which kind of a random variable? Like what will be the nature of x? It will be mixed random variable, right? Say yes or no. Why it is mixed random variable? Because you can see the sudden jump as well and you can see the continuous graph as well. You can see the sudden jump continuous graph, sudden jump, continuous graph, right? So it will be a mixed random variable. Otherwise, if it was only discrete, then staircase would be there. If it was only continuous, then only continuous graph would be there, right? But staircase is also there and a continuous graph is also there. That's why it is mixed random variable, right? Now between -1 to 3, you need to find the probability between -1 to 3, including the 3. So higher limit included, lower limit not included. So this is the desirable condition that we want. So fx of 3 minus fx of -1, and this would be equal to fx of 3 plus, this would be equal to -1 plus, right? And how do you, and you can think about it, you can think as well, fx of 3, that means everything including the 3 as well, and this is what I want, minus fx of -1, everything excluding the -1 and rest of the things. That means between -1 to 3, including the 3 as well. So fx of 3 plus 3 would be somewhere here, fx of 3 plus would be 1, fx of -1 plus, fx of -1 plus, that would be 1 by 2. So answer is 1 by 2. Okay, so this is the answer, A, B, C, D, right? What about E? -1 to 3, -1 to 3. So fx of 3 plus is 1, fx of -1 plus, fx of -1 plus is 1 by 2. So 1 minus 1 by 2 would be 1 by 2. What about E? 1 to 4. Here I don't want the, sorry, here I want the equal sign and here I don't want the equal sign. So problem is there at higher limit as well and lower limit as well. Fx of 4 minus fx of 1 minus. So what is the value of fx of 4 minus? That is 1 only, because 4 will be somewhere here, here will be 3, here will be 4. So the value is 1. Fx of here 1, no, 1 minus is 1 by 2. So here also the answer is 1 by 2, right? Because 1 minus is 1 by 2, 1 minus is 1 by 2. So this is the answer. So this is how you can answer very easily, right? If the graph is given, this is how you can answer, right? So all the discussion we are solving now with respect to the questions. Now we need to study about probability density function. We will study about it and then we will solve questions as well. A lot of questions we are going to solve. Just we will see the concept of probability density function and then we will solve the problems. But I need to take a break. I will take some break. I will drink some water and then I will come back. So you in this time just revise everything. Whatever that I have taught, just revise everything. Just revise this slide and revise this slide. Try writing down all kind of expression on your own. This expression is very important. This expression is important for solving the problems if graph is given. If graph is given, then this expression will be useful. Here graph was given, this expression was useful. But if graph is not given and directly they are asking this kind of question, then this particular expression will be useful. So we will see that, right? But first let's study about PDF, then solve some problems, right? So let me take a break and then I will come back. Yeah, welcome back. So now we are going to study about probability density function, PDF. Last time what we studied, probability mass function and cumulative distribution function. What was probability mass function? Probability at a point. This was your probability mass function. And what was your CDF? That was random variable x takes value lesser than or equals to small x. This was your PMF. This was your CDF. Now what is this PDF? So PDF is not the probability at a point. A lot of people have this doubt that sir, PDF represents the probability at a point. No, PDF is not the probability at a point. So this thing should be there in your mind. So what does the PDF show? PDF shows the density of the probability around a particular point. What it shows? Density of the probability around a particular point. Let's understand this with respect to example. Okay, let's understand with respect to example. So a group of students typically takes 30 minutes to 60 minutes to solve a particular quiz. This kind of example we have already seen. A random variable x is defined such that it represents the time taken by a randomly selected student to solve a particular quiz, right? So x can take continuous values from 30 to 60. X can take continuous values from 30 to 60, right? So the PDF of random variable x has been shown. So this is how they have shown the PDF of random variable x. Between 30 to 60 they have shown. So if what this PDF is representing, so this PDF will tell you that around 40 minutes there is maximum amplitude. No, what I mean to say is that fx of x, this is how you represent the PDF. Okay, how we used to represent the PMF? How we used to represent the PMF? PMF was represented by small p x of x, right? how we represent CDF? This is how CDF was represented. And how we represent the PDF? So PDF is represented small f, capital X, small x. Okay, so this is how we represent PDF. So this particular PDF function have been made. So what do you see? Fx of x is maximum when x is around 40, not x equals to 40. When x is around 40, you are getting maximum amplitude of the PDF. You are getting the maximum amplitude here. That means in the class, most of the students are solving the quiz around 40 minutes. What I am saying, in the class, most of the students are solving the quiz around 40 minutes. This is the meaning of a PDF, a probability density function. So it is showing the density. It is showing the density that most of the students are lying in this range. After that, most of the students are lying in this range. After that, minimum of the students are lying in this range. And none of the student is lying in this range. That means no one is taking more than 30 minutes, no one is taking less than 30 minutes. Are you able to understand this point? So it shows the density. It doesn't show the probability at a point. If I ask you what is the probability such that the student is taking exactly 40 minutes, that would be 0. But around 40 minutes, it would be the maximum. Are you able to understand this point? That most of the students are solving the quiz around 40 minutes only. Some are solving in 39 minutes, some are solving in 41 minutes, some are solving in 39.5 minutes. But around 40 minutes, you are getting the maximum value. Is that clear to you or not? Okay. So let's go to the previous slide. So what is your PDF actually? So PDF is nothing. It is just the differentiation of CDF. It is just the differentiation of CDF with respect to X. So whatever the CDF graph you are having, if you just differentiate it, you will get your PDF. Okay. So CDF is nothing but the differentiation. PDF is nothing but the differentiation of CDF. So when you differentiate the CDF, you will get the PDF. Are you able to understand this point? Okay. We will see more points. Everything will be clear. Have some patience. So CDF of random variable is represented by capital Fx of x, and PDF is represented by small fx of x, right? And differentiation of CDF is equals to PDF. What I am saying, differentiation of CDF is equals to PDF. From this equation, if you want to get fx of x, what you will do? This differentiation will go this side, it will turn into integration. Let me know what will be the limit. If you have studied signal system, you will be able to tell the limit. The limit will go from minus infinity to x, right? So from PDF, if you want to get CDF, from PDF, if you want to get CDF, that means you need to integrate, taking the limit minus infinity to x. And from CDF, if you want to get PDF, then you differentiate the CDF. Is that clear to you? So differentiation of CDF is equals to PDF, and integration of PDF is equals to CDF. Is that clear to you? PDF dot dx I will write down is equals to CDF. Is that clear? Okay. So first we understood the meaning of PDF. Secondly, we saw that what is the mathematical expression. Mathematical expression is just you get the CDF and then you differentiate it. This is the mathematical expression. We will see a lot of concepts, we will see a lot of problems as well. We will see the properties as well. So let's see this particular question. Probability such that your x is between A to B, including B, excluding A. So that can be written as fx of B minus fx of A, or it could be written as, because at higher limit I want the equal sign, at lower limit I don't want the equal sign. So this is the desirable condition, and I know that fx of B is equals to fx of B plus, and it is equals to fx of A plus. Now what do you know? That your fx of x is equals to minus infinity to x small fx of x dot dx. Do you know this? Right? So what would be your fx of B equals to? That would be equals to, in place of small x you need to put B. Say yes or no. Are you able to understand this point? Look, here I am writing down this particular thing that is not actually correct. Why it is not correct? Look, you are putting the limit in terms of x, and here also you are writing down x only. This point I explained in signal system as well, and here also I am explaining. Let's just say I am doing this particular differentiation, and then I say that I am putting the limit of x from 0 to x. Does that make sense? Although you can get the answer x cube by 3, 0 to x you will put, so answer will be x cube by 3, or you can take minus 1 here, whatever you want to take. But it actually doesn't make sense. No, you are integrating with respect to x, and the limit you will put of x only in terms of x only. This doesn't make any sense. Although answer will be x cube by 3, you can get the answer, but actually it should be written in this form, no? That in place of what was the differentiation, this, sorry, what was the integration, this was the integration, but actually this should be written in this manner, t square dot dt. So in place of x I am just putting t, so what I will get, t cube by 3, and now I can put the limit from 0 to x. So I am putting the limit of t now in terms of x. I am putting the limit of t in terms of x. So what answer I will get, x cube by 3 again. So writing this down is not making much sense actually. It is not making much sense, right? So here the important part is this should not be written in this manner actually. Although in textbook as well or in a lot of notes as well you will find out that PDF and CDF relation is written like this, but actually this should be written in this manner, that always you need to change the variable. So I am changing the variable by u, because here people will have a doubt that sir, in place of x if you are putting b, so here also you need to put b. No, this is just your function, and here also u, right? F of u, u du. This is the capital U, this is the capital U, and these are the small u. So I need to differentiate. This is the capital U, these are the small u. Are you able to understand this point? So here also I should have taken care that instead of writing x here I should put u. Are you able to understand this point? Just mathematics it is, nothing else. It is mathematics, nothing else. U does not look like good, right? Because here you cannot differentiate. Let's put q here. Okay, let's put q, because q you can make small q and capital Q differently. So in place of x I am putting q. So here also in place of x I will put q only. Right, minus, what about this one, minus infinity. In place of x you need to put a, because here you are having a, here you are having x. So in place of x you are putting a, right? You agree to this point? Let's take it downward a bit. So this does not make much sense, this makes the sense. Now what I will do, I will do is that I will interchange this limit. In the integration you know that if you interchange the limit, minus sign will turn to plus sign. So this minus sign will be turned to plus sign if I interchange the limit. So how will I interchange the limit? So this minus infinity to a, I am writing down a to minus infinity. Is that clear to? A to minus infinity. Fq of q dot dq. This negative sign has become to positive sign because you are interchanging the limit. And what about this one? This remains as it is. What you can see from here? A to minus infinity and then minus infinity to b. What does that mean? Do you remember this particular thing? A to b plus b to c. That means the limit of integration can go from a to c, right? You are going from a to b, then you are going from b to c. So it can go from a to c as well. So what is the answer you are getting? A to b, fq of q dot dq. So this is the answer of your probability taking value. And one more thing, in place of a, what you can put? In place of a, you can put a plus. In place of b, you can put b plus. So a plus, b plus, fq of q dot dq. So this is the answer you are getting, which you will be remembering, right? What about this one? What do you think? Okay, here just the conclusion I need to write down. So on the on the higher limit you want the equal sign, on the lower limit you don't want the equal sign. That means yes, this is the desirable condition. You are going from a to b, you are going from a to b. What you will do, you will just calculate the area of the PDF. Let's just say this PDF is given. What we can do is that we can kind of make a diagram as well. Let's just say this particular PDF is given. these are two any random point. What you need to find? From A to B you need to find. You need to find the probability such that your random variable x is lying between A to B. So what you will do? You will calculate the area. Taking the limit from A to B. Taking the limit from A to B. This is the PDF given. PDF will be given in terms of x, right? PDF will be given in terms of x. Now since the limit is constant, so now I can write down x, no? Are you able to understand this point? What I am saying? Since the limit is constant now from A to B, so now I can write down x here. I am just replacing q with x, nothing else. So from A to B you need to calculate the area, nothing else. Here what will happen? On the higher limit you want the equal sign, but on the lower limit you don't want the equal sign. That means lower limit is having some problem, but higher limit is not having any problem. But always remember in your mind that A is equals to A plus, B is equals to B plus, B is equals to B plus, right? What about this one? Again the integration, fx of x dot dx, again you need to integrate. On the higher limit you want the equal sign, on the lower limit you don't want the equal sign. So lower limit is not having any problem, but higher limit is having any problem. On the higher limit you want the equal sign, but it is not there. On the lower limit you don't want the equal sign, but it is there. That means both are having some problem. If both are having some problem, that means there you go. Is that clear to you? All good? All fine? Right? So the same way that we wrote down in case of CDF, in the similar manner we can write down in terms of PDF as well. So what if the diagram of PDF is given and they ask you the probability at probability in some range? Then you will be able to tell the probability in some range as well, right? And here I did not write one point. What if they ask you probability at a point? What if they ask you probability at a point? So what will be the answer for this one? Probability at a point, you will go from A minus to A plus, right? Fx of x dot dx. So they are asking me probability at a point. So I will go from A minus to A plus, A minus to A plus, and then I will calculate the area. So PDF simply means calculating the area, nothing else. PDF simply means calculating the area. I will go from A minus to A plus. And just think about it. If your PDF is continuous, then what will happen? You go from A minus to A plus. What will be the area? If I am making this particular graph, and let's just say this point is 2, and I ask you, I am going from 2 minus to 2 plus. What will be the area? 0 only, no? 2 minus to 2 plus, that means there is no width. There is height, but there is no width. If there is only height, what is the area? 0 area, right? So probability at a point for continuous random variable will be 0. So we will see all these examples, everything will be clear to you. As of now, you just keep on seeing what I am telling. So I am telling probability in a range from A to B. B is not having the equal sign. Sorry, B is having the equal sign, but A is not having the equal sign. This is our desirable condition. That means both A plus B plus. But this is not the desirable condition for the lower limit. That's why A minus. This is not the desirable condition for higher limit. That's why B minus. And this is not the desirable condition for lower limit as well, for higher limit as well. That means A minus, B minus. Well and good. Let's see the properties. So what do you know? That your PDF is just the differentiation of CDF, right? PDF is differentiation of CDF. And you know one particular thing, that your CDF can never be decreasing. It can be constant. It can be increasing, but it can never be decreasing. That means slope will always be positive or 0. Slope will always be positive or 0. That means what is the meaning of differentiation? Differentiation means slope only, right? The meaning of differentiation is slope. What is the meaning of differentiation? Differentiation means only the slope. So if your fx of x is non-decreasing, that means slope will never be negative. Slope will be either 0 or it will be positive, because it will either increase or it will remain constant. So here the slope is 0, here the slope is positive, here the slope is 0. So slope will either be 0 or it will be positive. So your PDF will never be negative. What is the meaning? PDF will never be negative. It can be 0 or it can be positive. If I want to find probability from minus infinity to infinity, let's just say here I put the equal sign. So what I will do, fx of infinity minus fx of minus infinity. What is the meaning of fx of infinity? That means probability such that random variable x is taking value lesser than or equals to infinity. The value is 1. And what is the meaning of fx of minus infinity? Probability such that random variable x takes value less than equals to minus infinity. That would be 0. So between minus infinity to infinity, your probability will be 1. And it is very obvious, no? Just think about it. Your random variable will take any value between minus infinity to infinity only, no? If it is taking 0 value, it is taking some continuous value, whatever the value it will take, it will always be between minus infinity to infinity only, no? Are you able to understand this point? And how this particular thing could be written? This particular thing could be written in this manner, right? We have seen it, right? Fx of b minus fx of a. Fx of b minus fx of a was written as a to b and then integration. Here fx of b minus fx of a, it was written a to b and then the integration. Similarly, from minus infinity to infinity, then this is how it will be written, that you need to integrate from minus infinity to plus infinity. So what that would be equals to? So this particular thing is equals to 1. That means this particular thing will also be equals to 1. That means area under the PDF curve will be equals to 1 only. Are you able to understand this point? Basically, whatever your PDF is drawn, let's just say any PDF is drawn, any kind of PDF could be drawn. The area under the PDF curve will be 1. This kind of, let's just say this kind of a PDF is drawn. It could be decreasing as well. Never ever I said that PDF could not be decreasing. PDF could be decreasing, but it should be positive. That's the only condition. That this is how your PDF is drawn. This is how your PDF is drawn. It is your fx of x versus x. So if you calculate this particular area, if you calculate this particular area will always come out to be 1. This area will be 1. Why is that so? Because you know that from minus infinity to infinity, x will take all the values. That means probability should be 1 only. Is that clear to you? And how do you write down this particular thing? You write down this particular thing as, you go from a plus to b plus fx of x dot dx. So this slide and this particular slide both are very important. So for PDF, what did you understand? It can never be negative and the area under the curve should be 1. That's it. Only 2 conditions. What all are the 2 conditions? For CDF, what was the condition? For CDF, what was the condition? It will rise from 0 to 1 in a non-decreasing manner. What will be the condition for PDF? Always not negative. I am just writing not negative and area under the curve is 1. Not negative and area under the curve is 1. This is the condition for PDF. So let's solve a question. X is again the number of heads appearing when 3 coins are tossed simultaneously. So this we have already seen. That means X will take values from 0, 1, 2, 3, right? So we know how to draw the PMF, right? This was equals to 1 by 8. This was equals to 3 by 8. This was equals to 3 by 8 and this was equals to 1 by 8. So can you draw the PMF? Yes, we can draw the PMF. Where is the PMF that we have drawn? So PMF was drawn here. This was the PMF that we have already drawn. So this is how the PMF will look like. And can you draw the CDF as well? Surely I can draw the CDF as well, because for the same example we have seen the CDF as well, right? For ditto same example we have seen the CDF as well. So this is how I can draw the CDF as well. Next task would be to draw the PDF, right? So this is the CDF that we have drawn. Now we need to draw the PDF. What did I tell you? What is your PDF? PDF is fx of x. What that would be? Differentiation of CDF. So what you will get? Can you differentiate this particular curve? I hope you know how to differentiate. So starting from here, 0. Then there is a sudden jump of 1 by 8. That means here what will come? Impulse of area 1 by 8. Then 0, 0, 0, 0. Here what is the slope? Here what is the slope? If I ask you the slope here, slope is 0. But here there is a sudden jump. Here there is a sudden jump. Here there is a sudden jump. Here also there is a sudden jump. So wherever there is a sudden jump, slope is infinity. But in electronics, how do we show infinity? We show the infinity by impulse. Impulse of some area. Impulse of area 1 by 8. Okay. Then impulse of area 1 by 2 minus 1 by 8, what that would be? 1 by 2 minus 1 by 8, that would be 3 by 8. Now 7 by 8 minus 1 by 2, what that would be? 7 by 8 minus 1 by 2, that would also be 3 by 8. And then 1 minus 7 by 8, that would be 1 by 8. So slope 0, 0, 0, everywhere 0, just only you need to see the sudden jump. So 1, 2, 3. 3 by 8, 3 by 8, 1 by 8. So wherever there is a sudden jump, you will have an impulse of area equals to the jump. So jump is equals to 7 by 8 minus 1 by 2. How much jump is there? 3 by 8 jump is there. Then again 3 by 8 jump is there. Then 1 by 8 jump is there. And here in the beginning as well, 1 by 8 jump is there. Right? So this kind of a PDF you are getting. So this is your PDF. If you closely see the graph of PDF and the graph of PMF. So it is the same, just these discrete sequences have become impulses. These discrete sequences have become impulses. But this is true for your discrete random variable. For discrete random variable, we have drawn PMF as well, we have drawn CDF as well, and we have drawn PDF as well. For continuous random variable, your PMF will always be 0. But for continuous random variable, PDF will not be always 0, right? For continuous random variable, we have seen this kind of PDF, no? This kind of PDF we saw. So for continuous random variable, PDF will not be 0, but it will never have the impulse. Whenever you see impulse, in case of CDF, whenever you see sudden jump, what will you understand? That the random variable is discrete. And in case of PDF, whenever you see impulse, because in CDF if there is sudden jump, that means in PDF there would have been impulse, no? Because if you differentiate the sudden jump, what do you get? You get impulse. When I differentiate the sudden jump, I get impulse. So in your CDF if there is sudden jump, or in your PDF if there is impulse, that means it is discrete random variable. And if the graph is continuous, then it is continuous random variable. Are you able to understand this point? Continuous means continuous random variable. And if you see sudden jump in CDF, that means it is discrete random variable. And in PDF, if you see impulse, that means it is discrete random variable. Is that clear to you? Although it will not be asked, I'm just telling you that looking at the PDF, can you let me know what kind of random variable we are going to study? Yes. So we saw this example. This was purely discrete random variable. So only impulses were there. Are you able to understand this point? Right? Okay. And if someone asks you from this particular PDF, if someone asks you what is the probability at x equals to 1, what you will do? From 1 minus to 1 plus, you will calculate the area. From 1 minus, here there will be your 1 minus, this will be your 1 plus. So from 1 minus to 1 plus, you are having an impulse of area 3 by 8. This would be your answer. Are you able to understand this point? Right? So probability at a point is non-zero for discrete random variable. This is a discrete random variable. So probability at a point is non-zero for discrete random variable. But if it was a continuous random variable, then probability at a point would be 0 only. We will see the example. It will be more clear to you. Let's see this question. So can you let me know what kind of random variable we are studying here? What kind of random variable x would be? X would be what kind of random variable? So here you can see that graph is continuous as well. Along with that, you are having an impulse as well. So surely 3 by 2 a different value it will take. Otherwise, it will take the continuous values. Here, what do you understand? How much values your random variable x is taking? So x is taking one discrete value, that is 3 by 2, and continuous value between -2 to 2. Are you able to understand this point? Okay. So this is a kind of PDF is given for random variable x. So continuous values are also there, discrete values are also there. So it is your mixed random variable. Although this doesn't make much sense, but yeah. Okay, practically this example will not be possible. Theoretically you can make any kind of curve, but practically this example will not be possible. Theoretically it is fine. First you need to find the value of alpha. What do you think? How will I find the value of alpha? I know one thing, the area under the curve will be 1. For PDF, area under the curve, what I need to find? I need to find the value of alpha. So for PDF, area under the curve is always 1. That means what do I know? From minus infinity to infinity, fx of x dot dx would be equals to 1. So we need to find this particular area, this area, this area, and then there is an impulse as well. So let's find the area. Okay. So between minus infinity to minus 2 everything is 0, between 2 to infinity everything is 0. So I need to care about only between minus 2 to plus 2. So what will be the area? Here this is a triangle. So half into base is 3, height is alpha, plus what about this? So this particular structure will have an area of half into addition of parallel side alpha plus 0.7 into the height which is 1. That's it. This is the area. No, this particular area is also there, no, because this is impulse, plus alpha by 10. So this will be equals to 1. This is triangle. Then this particular structure, this will have the area of half into, or you can find it out in this manner, that this is a triangle and this is a rectangle. In that as well you can find. In that manner as well you can find. So you will get the same answer only. 0.5 plus half into base will be 1 into height will be 0.2. Wait a second. Yeah, sorry. Here I did a mistake. No, here I did a mistake. Sorry. Let's not do it. Like, basically find the area like this, that there is a triangle and then there is a rectangle. So what will be the area of the triangle? Half into base. What is the base? 0.2. Sorry, base is 1. And what is the height? This height is 0.2, right? This height is 0.2. Plus, what about this rectangle? So will you take alpha or 0.5? Basically this is the rectangle, no? So I need to take 0.5. No, I took alpha previously. So 0.5 into 1, that will be the area of a rectangle, right? Are you able to understand this point? So this is how I need to write down. I could have applied this formula as well, half into addition of parallel side. So parallel side would be these two sides, 0.5 plus 0.7, that would be 1.2 into the height, that would be 1. So 0.6 you will get. So in both of the cases you will get 0.6. So what you are getting actually, you are getting 1.5 alpha, 0.1 alpha, 1.6 alpha, 1.6 alpha plus 0.6 is equals to 1. So alpha value you are getting as 0.25, right? Yeah. So alpha value is coming out to be 1 by 4. This is the value of alpha that you are getting. Okay. Next question. Probability at x equals to 1. Probability at x equals to 1. Probability at a point. So what you will do? 1 minus to 1 plus fx of x dot dx. What will be the answer? 1 minus to 1 plus. That means the width is 0. Look, basically if there is no impulse, and I ask you that I am calculating the area from a minus to a plus. So this particular width is 0 only, no? Your answer would be, sir, this amplitude, whatever the amplitude is, alpha into the width. A minus to a plus, what is the width? 0 only. So what is the answer you are getting? 0. But if there is an impulse and I ask you the area from a minus to a plus, then that would be equal to the area of this particular impulse, and that impulse, let's just say it is having amplitude of 3 by 2, so the area will be 3 by 2. So if the graph is continuous, then there is no meaning of area between minus a to minus 1 minus to 1 plus, the area would be 0 only, and you can directly see the graph is continuous. That means probability at a point will be surely 0. This area is 0. How will you find probability at 3 by 2? So you will take the area from 3 by 2 minus to 3 by 2 plus. Now here what you can see, here you can see that there is this impulse present. From 3 by 2 minus to 3 by 2 plus, this impulse is present, and this impulse is having an area of alpha by 10. So alpha by 10 would be the answer, and that would be equals to 1 by 40. And what about the last one? In the range minus 1 to 3 by 2, probability not minus 1, it is 1, from 1 to 3 by 2. Now you let me know one thing. At 3 by 2, do you want the equal sign? Yes. At 1, do you want the equal sign? No. That means you are having problem at both of them. So what you will take? 1 minus 2 3 by 2 minus fx of x dot ds. 1 minus would be this point only. That means 1 minus is equal to 1 plus only basically. 1 minus, what will be the amplitude at 1 minus? That would be alpha. What will be the amplitude at 1 plus? That would also be, amplitude at 1 plus will be different. And what will be the amplitude at 1? That would also be different. Basically 1 minus would be this. You need to calculate the area from here to 3 by 2 minus, but the impulse is there at 3 by 2. That means this impulse will not come into action. Are you able to understand this point? A very, very important point. This impulse will not come into action, no. You need to calculate the area from 1 minus to 3 by 2. 1 minus to 3 by 2. 1 minus 2, this is your 1 minus. 2, 3 by 2 minus. So impulse is there at 3 by 2. So this impulse will not come into action. Right? So what all things will come into action? So this area I need to calculate now. Say yes or no. So this is your alpha. This was your alpha, but area you are calculating, no, basically this area you are calculating. This area you are calculating. Right? This particular area you are calculating. So here what will be this amplitude? 0.5. And here what will be this amplitude? What is the slope? Slope is 0.1. So this amplitude will be 0.6. Like, have you studied mathematics? If you have studied mathematics, you know that what is the slope here? 0.2 divided by 2. The slope is 0.1. That would be equal to y2 minus y1, y2 minus y1 upon x2 minus x1, x2 minus x1, x2 minus x1, y2 minus y1. y2 value you don't know. So 0.1 is equal to y2 minus 0.5 divided by 0.5. So this will be 0.05. 1 say 3 by 2. You are covering the half distance. 0.5. What is the slope? So sorry, slope is 0.2 only, no, really sorry guys. The difference 0.2 divided by 1, slope is 0.2 only, no, slope is 0.2, slope is 0.2. This divided by this, the slope is 0.2. So 0.2 is equal to this, so y2 is coming out to be 0.6. So this particular width is 0.5 to 0.6. So this particular area I need to calculate. So what is this area? This area is half into addition of parallel side, that would be 1.1 into this width, that would be 1.1 divided by 4. This would be the answer. We will not add alpha by 10 here. This is the very, very important point. Here this 1 by 40 will not be added. This will not be added. Okay, because what they asked, 3 by 2 should not be included. The probability at 3 by 2 should not be included. So just before 3 by 2, just before 3 by 2. So from 1 minus to 3 by 2, this area we need to calculate. Look, someone will say that, sir, from 1 minus to 1, what will be the area? You are actually calculating the area from 1 to 3 by 2. Yes, I know that I am calculating the area from 1 to 3 by 2. But from 1 minus to 1, what will be the area? That would be 0 only, no? If I need to calculate the area from 1 minus to 3 by 2 minus, so I can calculate the area from 1 to 3 by 2 as well, no? Because at 1 there is no impulse. If there is an impulse, then there is a difference between 1 minus to 1. If there is no impulse, then there is no difference. So area from 1 minus to 1, that would be equal to 0 only. From 1 to 1 plus, that will also be equal to 0. But from 3 by 2 to, from 3 by 2 minus to 3 by 2 plus, the area would be different. What I am saying, from 3 by 2 minus to 3 by 2 plus, the area would be different. The area is alpha by 10. But from 1 minus to 1 plus, the area would be 0 only. Here we have seen 1 minus to 1 plus, the area would be 0. But from 3 by 2 minus to 3 by 2 plus, the area would be different. And then we calculated this particular answer. Right? We calculated the area here. The important part was what will be the amplitude here, that would be 0.6. Okay. You solve this question. Which of them are valid PDF? I will take a break. I need to drink some water and then I will come back. Okay. So you solve this question. Yeah. Welcome back. So did you try this question? So what is the condition for PDF? We already wrote down that it cannot be negative. It cannot be negative and area under the curve should be 1. There is nothing about increasing, decreasing, right? There is nothing about increasing, decreasing. It can decrease as well. Only two conditions are there. It cannot be negative and area under the curve should be 1. Is it negative? No. Area under the curve is 1. Yes. Is it negative? No. Area under the curve is 1. Yes. You can see 10 into 0.1. That would be equal to 1 only. Correct. Is it negative? No. Area under the curve is 1. Yes. 0.75 plus. Is it negative? No. Area under the curve is 1. Yes. 1 by 4 into 2 plus here 0.5. So 0.5 plus 0.5, that would be 1. Is it negative? No. So that means this is also valid. What about this one? Negative. Negative. Forget about the area under the curve. It cannot be negative. If it is negative, then not valid. Right? Area under the curve could be 1, but it cannot be negative. That is the required condition. Let's go to the next question. PDF of random variable x is given. Now you will say that, sir, PDF of random variable x is written by this particular thing. But the examiner can show the function in any manner, no? What I am saying, examiner in the examination, the examiner is showing the function like this. Although usually it is shown by like this, but examiner can show the function in any manner, right? So what they have given? They have given the PDF. What you need to find? You need to find the value of k. So what you will do? You already know one thing. Area under the curve should be 1. Area under the curve should be 1. And here limit also you need to see. It is going from minus infinity to infinity only. So that means yes, this limit will be from minus infinity to infinity only. Minus infinity to infinity k e to the power minus 3 mod of x dot dx. Is it a even function? Yes, it is a even function. So how you can break it down? 2 into 0 to infinity k e to the power minus 3x dot dx. So what will be the answer? This should be equals to 1. This should be equals to 1. So what answer you will get? When you solve this particular integration, you will get 2k by 3. That should be equals to 1. So value of k is coming out to be 3 by 2, which is 1.5. Very simple. Whenever you need to find out any constant value, just remember area under the curve is 1. So calculate the area and equate that equals to 1. So area was coming out to be 2k by 3. That should be equals to 1. So k is 1.5. A random variable PDF of random variable x is given. You need to find the CDF. So what is the relation between PDF and CDF? If PDF is given, you just need to integrate it. What you will get? You will get the CDF. So you need to integrate. What is this? Ramp. And this is also ramp only. So when you integrate a ramp, what you are going to get? Linear graph? No. Parabolic? No. When you integrate a ramp, what do you get? Parabolic. Integration of t dot dt. What that would be? T square by 2. So basically square kind of relation will be there. Linear relation will not be there. Square relation will be there. So this kind of relation will be there. So this answer is correct. Right? Very simple questions. Right? And this answer would be wrong. PDF is given, you need to find the CDF. Again, this time expression is given. A is greater than 0, B is greater than 0. You need to find the CDF for x greater than 0. Condition is for x greater than 0, you need to find the CDF. So what I need to do? What will be my CDF? that will be integration of PDF. Can you draw the graph of PDF? Surely I can draw the graph of PDF. Will it be an even graph? Yes. At x equals to 0, the value will be a. At x equals to infinity, value will be 0. And the graph is even because in place of x, if you put minus x, you get the same graph. So graph is even. So this will be the graph of your PDF. Here what they are saying, here if I am putting the limit of x, so here I should not put x, right? I should put q. If I am putting the limit of x, sorry, if I am putting the limit in terms of x, then here I should put q, right? So here I will say that I have drawn the graph of, basically I know fx of x, then I know f, if I know fx of x, then can you let me know what will be your fq of q? That would be equals to a e to the power minus b q. So you need to find the CDF such that your x is greater than 0. That means I need to find the CDF such that your q is greater than equals to 0. So this is my q. So fq of q I am drawing with respect to q, and this q is here, or sorry, the thing is, really sorry guys, the x should be greater than 0. That means this limit is greater than 0. This is what they are saying. Basically you are integrating from minus infinity to x. You are integrating from minus infinity to x. So x should be lying here. It should not be lying here. So x is lying here. X is greater than 0. So can I break down this limit something like this? Minus infinity to 0 fq of q dot dq plus 0 to x f q of q dot dq. Do you agree to this point? Because x is greater than 0, no? That's why this information is given. Because some guys may understand that x is here. That means they will consider only this particular graph. But x is greater than 0. That means this graph should be considered. Also this graph should also be considered. So between minus infinity to 0, what kind of relation, what kind of expression you are having? What I mean to say is that, can you write down the expression of fq of q in this manner? That what do you get x greater than 0 and what do you get x less than 0? So when x is less than 0, so this graph will be opened, mode of x will be opened with minus x. These kind of calculation we have done when we studied convolution, right? And for x greater than 0, it will be opened as plus x only. So this is the graph. Okay, it will be opened as minus x, so this will become, x will be replaced with minus x. For x less than 0, mode of x is minus x, right? So this will become a e to the power bx, and this will become a e to the power minus bx. Is that clear to you? And since here in place of x we are putting q, is that clear to you? Surely it is clear to you. So minus infinity to 0 a e to the power bq dot dq plus 0 to x a e to the power minus bq dot dq. So what you will be getting? Do you have the page? No, I have to add a page. So you are integrating with respect to q. So a e to the power bq divided by b. So minus infinity to 0. You are putting the limit of q now, right? And then again here as well, a e to the power minus bq divided by minus b from 0 to x, right? So what I will get? A by b is constant. So from the first one I can take out a by b. Now I am putting the limit of q. So 0 I will put and 1 I will put. So a to the power 0 minus, here I will put infinity. So this will be 1 minus. I can take out minus a by b, because minus sign I am taking out, a by b I am taking out. So here I am getting a by b. So put the limit of x e to the power minus bx, and then put the limit q equals to 0, you will get 1. A by b minus sign I took out. So here it will be a by b. Here what you are getting? A by b e to the power minus bx minus 1. So this is the answer you are getting. Or what you can do, So this will actually become 2a by b minus a by b e to the power minus bx. Can you understand this point? Basically minus a by b is there, a by b e to the power, what I mean to say is that let's keep a by b as it is, minus a by b e to the power minus bx plus a by b. So that would be equals to 2a by b minus a by b e to the power minus bx. So a by b 2 minus e to the power minus bx. So your fx of x is coming out to be, just it was purely based on integration, nothing else. With this particular question, I just wanted to test the integration, nothing else. There you go. This is what we are getting. Is this correct? Like, is there any calculation mistake? Let me check. E to the power minus bx, power minus bx minus 1, minus 1, minus sign is there outward. A by b minus a by b to the power minus bx. This minus sign will become plus sign to a by b. A by b 2 minus a to the power minus bx. Yeah, there you go. This is the answer you are getting. Considering the fact that you are taking x greater than equals to 0. So what could be the other way of writing it down? The other way could be a by b 2 e to the power minus x u of x. But considering x greater than equals to 0, for x less than equals to 0, the answer would be different, right? Are you able to understand this point? This is the answer that you are getting for x greater than equals to 0, because this is what is asked in the question. But in the question, what if they have mentioned x is less than 0? For x less than 0, what answer you will get? For x less than 0, you will integrate from minus infinity to x till this point. Are you able to understand this point? Basically, your fx of x would be, I will sorry, what you need to find, this is, sorry, really sorry guys, this was your CDF, right? This was your CDF, not PDF. This was your CDF, right? So what you will do for x less than 0, what you will do, I will integrate from minus infinity to x only. I will integrate from minus infinity to x, but now your x is less than equals to 0. If it is less than equals to 0, that means somewhere here it will be lying. If somewhere here it will be lying, then that means your fx of x or fq of q will be this particular function only, right? So it would be a to the power bq, because only in this range you are integrating. So this particular function is a to the power bq, and this particular function is a to the power minus bq. So a to the power bq dot dq. So when you integrate it, what you will get? A by b e to the power bq minus infinity to x. So what you will be getting? A by b e to the power bx. This is what you are getting for x less than 0. So now what is your complete expression of fx of x? Let's not put this in the box. Complete expression of fx of x. Although this is a gate PYQ, so in the gate PYQ they only asked for this condition, but this is the answer that you are getting for x considering less than equals to 0. Are you able to understand this particular analysis, right? X could be greater than 0, x could be less than 0, because x is a varying limit, no? The limit is varying. So it could be greater than 0, could be less than 0. If it is greater than 0, that means this graph is also coming into action and this graph is also coming into action. So this particular graph is coming into action from 0 to x, and this particular graph is coming into action from minus infinity to 0. So we got this particular answer, and here we have got this particular answer. Answer for less than 0 is coming out to be this, and answer for greater than 0 is coming out to be this. So this is your complete fx of x that you are getting. So for less than 0 you are putting u of minus x, for greater than 0 you are putting u of x. So this is your complete fx of x. This is the complete answer. In the examination only this particular thing was asked. but the complete expression can also be asked. Is that clear to you? Right? And here someone will say that, sir, what is the value of fx of minus infinity? So if you put fx of minus infinity, that means this is already gone, because u of x is 0 at x equals to minus infinity. And if you put minus infinity here, what you will be getting? A by b e to the power minus infinity. That would be 0 only. So fx of minus infinity is coming out to be 0 only. And what is your fx of infinity? Sir, if I put fx of infinity here, that means in this expression I will put fx of infinity. Basically, this particular expression is valid for x less than 0. And this particular expression is valid for x greater than 0. So if I put fx x equals to infinity, then I will care about this particular expression. If I am putting x equals to minus infinity, then I am caring about this particular expression. So here I put x equals to minus infinity, I am getting 0. Here I put x equals to plus infinity, what I am getting? 2a by b. If I put plus infinity here, so e to the power minus infinity, that would be 0. So I am getting 2a by b. And actually, what should be the value of fx equals to infinity? That should be 1. So your 2a by b should be equals to 1. And surely it is 1 only. Why is that so? Because what will be the area of this particular thing? Can you let me know what will be the area of this particular thing? The area of this particular expression, basically what I am saying is that minus infinity to infinity fq of q dot dq. You do this particular expression. Basically, you find the area for this particular expression from minus infinity to infinity. What you will get? This will throw 1 by b. This will throw 1 by b. And here amplitude is a. So answer will be a by b. But the same thing will be happening towards the negative side as well. So your answer will be 2a by b. And that should be equals to 1. So 2a by b should be equals to 1. And here what you are getting 2a by b only. And that should be equals to 1 only, yes. So if they can ask this particular question as well, that what is the relation between a and b? So the relation is 2a is equals to b. Or this expression also they can ask. Or this only expression they can also ask. So a lot of questions can be asked from this particular question. Are you able to understand what we are doing? They could have given this particular expression and they asked you what is the relation between a and b. So what you will do? Area under the curve is 1. So you calculate the area, what you will get? A e to the power minus b mod of x dot dx. In signal system, I told you, just remember the answer of this particular thing. That will throw 1 by b. So this particular area is 1 by b. Amplitude is a. If amplitude was 1, then answer would be 1 by b. If amplitude is a, so here answer would be a by b. And similar thing is happening towards the negative hand side as well. So answer would be 2a by b. Is that clear to you? Right? And that should be equals to 1. So 2a by b should be equals to 1. And then we find out the expression of fx of x. Here also I can check that I know that fx of infinity should be 1. And what is fx of infinity is coming out to be? 2a by b. So that should be equals to 1. Right? Let's go to the next question. Find the probability in the terms of CDF and PDF. Okay, just this is kind of repetition only. So how you can write it down? Probability of x less than equals to 2 minus probability of x equals to 2. Is that clear to you? Why I put this less than equals to sign? Why I am always interested in this less than equals to sign? Because I know that this can be converted into CDF. So this would be fx of 2 minus fx of 2, probability of x taking values lesser than equals to 2 minus probability at x equals to 2. Because what this is saying, everything less than 2 but not 2. So that's why I subtracted the probability at x equals to 2. So this is how I can write it down. And in case of PDF, how I can write it down? I need to find probability less than 2. Probability less than 2. That means from minus infinity to less than 2. 2 should not be included. Probability less than 2. So minus infinity to 2 minus, I will calculate the area. There you go. What about greater than 2? Can it be written as? Say yes or no. Do you agree to this point? X should be greater than 2. So it can be written as 1 minus p x less than equals to 2. Because you know that probability x greater than equals to 2 plus probability x less than equals to 2 should be equals to 1. Because this will take all the values, no? If here is 2. So greater than 2 and less than 2, here including 2 as well. So 2 is also included, greater than 2, less than 2, everything is coming. So can I write it down probability of x greater than 2 as 1 minus probability of x less than equals to 2? Because if everything is included, that means probability will be 1. If I ask you probability from minus infinity to infinity, what is that? That is 1. And it can be broken like this. x greater than equals to 2 plus x less than 2 should be equals to 1. So probability of x greater than 2 would be 1 minus probability of x less than equals to 2, and it can be written as 1 minus fx of 2. And what about in terms of a PDF? So what you need to do? You need to go from 2 to infinity. 2 to infinity. You need to go from 2 to infinity, but excluding the 2. No, sorry. 2 plus to infinity, right? You are going from 2 to infinity. 2 to infinity, but 2 should not be included. That means you should go from 2 plus to infinity, right? This is your 2 minus. Here, why I am going from minus infinity to 2 minus? Because here 2 should not be included. So this 2 should not be coming into action. So I am going from minus infinity to 2 minus. And here 2 should not be included. So I will go from 2 plus to infinity. Is that clear to you? Or how you can write it down? Say yes or no. Can I write it down in this manner? This particular thing can be written in this manner. Say yes or no. 2 to infinity greater than 2 less than equals to infinity. X is greater than 2. So when lesser sign is there, I don't care about the equal sign. That means this is perfect. So 2 plus 2 infinity. If this is something that I required, then here 2 plus would be coming. If here this was the thing, then what would come? 2 minus would come, right? So this is how you can compare, or you can directly think as well. So this is how I am thinking as well. In short manner, you can write down here that what I just told. Similar question you could have solved in this manner as well. Right? Let's remove this equal sign, because infinity, at minus infinity, if you put equal or not equal, both are same. Now just let me know, this particular thing I am writing down as this, minus infinity to 2. Here you needed the equal sign, but it is not there. That means here I need to put minus, which I am putting directly here. Is that clear to you? Right? All good? All fine? Okay, yeah, that's it. Now x greater than 2. So this can be written as probability of x greater than 2. But I need to write down in terms of less than 2. So this can be written as 1 minus x less than 2. Say yes or no. Right? All good? But if I put an equal sign here, that means I am killing the 2 as well. But I don't need to kill the 2. I need probability at 2 as well. So this is perfect. Do you understand this point? What you need? Greater than 2. Everything including 2 and greater than 2. So what I did, complete is 1. Complete is 1. 1 minus everything less than 2 including the 2 I subtracted. Everything less than 2 and including the 2 I subtracted. So now what is subtracted? 2 is also gone and less than 2 is also gone. But what you need? You need 2 as well, no? So that's why I need to add probability at 2 as well. Is that clear to you? And why I am caring about this equal sign? Because you know, what do you know? You know that I care about this particular thing a lot. Which particular thing? This particular thing a lot. Right? And how you could have solved it if you don't want to use the brain? X greater than 2 you need, no? Right? That means x should be greater than 2, it should be less than infinity. So what will be your answer? Fx of infinity minus fx of 2 minus. Basically at infinity you put this or not, that doesn't matter. But here at the lower limit you don't need the sign. But at the lower limit you are getting the sign, that means 2 minus you need to put. What is fx of infinity? That is 1. So fx of 2 minus you are getting. Now I need the answer in this form. What I will do? I know that fx of 2 plus minus fx of 2 minus is equals to probability at x equals to 2. So now I need to replace fx of 2 minus. So what that would be? That would be equals to probability at x equals to 2. So fx of 2 minus probability x equals to 2 would be equals to fx of 2 minus. So this fx of 2 minus you can put here. Fx of 2 minus you can put here. So what you will be getting? This sign will become plus and this sign will become minus. So this is something you will get. So here no brain is used. Are you able to understand this point? We are not using our brain. Directly whatever that we know, from there we are solving the problem. So okay, I will write down all these points again. Okay, so on the next page I need to add a page. I will solve all the problem with respect to what? With respect to whatever that we remember. What is the first question? Probability of x less than 2. X less than 2. That means it can be written as from minus infinity to 2, right? So lower, no issue, but higher there is an issue. So 2 minus fx of minus infinity. What is fx of minus infinity equals to? That is equals to 0 only. So what is the answer you are getting? Fx of 2 minus. But you know one particular thing. What do you know? That probability at x equals to 2 would be given as fx of 2 plus, or 2 you can put, minus fx of 2 minus. So fx of 2 minus could be given as fx of 2 minus probability at x equals to 2. So what is the answer you are getting? Fx of 2 minus probability x equals to 2. So this was the answer we were getting. So here we used our brain, but here we used our method. Are you able to understand this point? Second one, probability x greater than 2. That means x is greater than 2 and less than infinity. You can put the equal sign here, doesn't matter. So fx of infinity minus fx of 2. Here you don't need the equal sign, which we are not getting. So answer is 1 minus fx of 2, which we were getting here. 1 minus fx of 2, right? And here minus infinity to 2 minus 2 plus to infinity, that you can do from here only, right? From here as well. If you see this particular thing, what you can see, you will take the integration from minus infinity to here you need the equal sign, which is not there. 2 minus fx of x dot dx. And what about this one? Here you don't need the equal sign. Here also here you need the equal sign, which is there. Here you don't need the equal sign, which is not there. So that means everything is perfect. So 2 to infinity dot dx. Now you will say that, sir, 2 plus you have written. So yeah, 2 plus also I can write down, because I told you 2 and 2 plus both are same. In our communication system, 2 and 2 plus are same, right? This I already told you. Third one, probability of x greater than 2, greater than equals to 2. So how you can write down? So here you need the equal sign, which is there, but this is creating the problem. So fx of infinity minus fx of 2 minus. What is fx of infinity? That is 1 minus fx of 2 minus. What is fx of 2 minus equals to? 1 minus fx of 2 plus probability at x equals to 2. So no brain is used here. Simple answer we are getting. Here we used our brain, but here simple way we have got the answer. Because the thing is, in the examination, brain doesn't work. Okay, in the examination, these method might be very helpful for you. If your brain is not working, then just go to the method, right? Because here on PrepFusion, we believe on both of the things, method as well and using the brain as well. Because eventually, when you get into the industry, or even if you get into the PSU, if you get into VLSI, wherever you go, you need to use the brain, not the method, right? Method are just to crack the examination. But cracking the examination is also important, because if you don't crack the examination, you won't get the admission. And if you are not getting the admission, then you will not be able to do well, right? It is very easy to say that examination doesn't define anything. Examination does define something, okay? The statement that examination doesn't define anything, that is absolutely wrong. This is very sad, but it is the harsh truth that your marks do matter, okay? Because if you don't get the marks based on the sympathy, no one will take the admission. No one will give you the job based on the sympathy, right? Even if you open your own organization, will you give anyone any job just based on the sympathy that this is a poor guy? If you are the CEO of the organization, no, you will not give, no. Because you know that I need to run my company. If I don't run my company, you can give him donation. You can give him some loan as well, but you will not give him job, right? So on sympathy, these things don't work. Your marks do matter. Sadly, it is the truth. So here what you will write down? 2 minus 2 infinity. Here as well you think about it. X greater than 2. X greater than equals to 2. Greater than equals to 2. Greater than equals to 2. So that means you will go from 2 minus to infinity. Are you able to understand this point? Here what do we see? Here equal sign is not required. So here we are having a problem. So 2 minus we are getting. Here also we will do the same thing. Greater than equals to 2. That means 2 should also be included, no? So I will go from 2 minus to infinity. Now someone will say that, sir, why 2 minus? We could have gone from 2 as well. We could have gone from 2 as well, because including the 2. But the problem is, let's just say, what if at 2 you are having the impulse fx of x? Here what if you are having an impulse? So if you are having an impulse at x equals to 2, then you cannot define the integration at x equals to 2, no? Basically, if I need to find out this probability, that means I need to take this impulse into action, because probability at x equals to 2 will be coming by this area. So if I am having the impulse here, that means I need to take the limit from 2 minus, no? So that this impulse becomes into action. Because I told you, for impulse, you will never define impulse, you will never define the integration of the limit at that particular point. You can never do 2 to infinity. You have to do 2 minus to infinity. So 2 minus to infinity. Right? Mod of x greater than 2. Can you solve it? So x should be greater than 2 and x should be less than minus 2. Right? Mod of x greater than 2. So if x is 3, 4, 5, everything will work. If x is minus 3, minus 4, minus 5, everything will work. So x is greater than 2, x is less than minus 2. So what you are saying? X is either greater than 2 or x is less than minus 2. So here for greater than 2 you have written, and less than minus 2 also you can write down. You can do it on your own, right? Basically here I cannot write down in this manner that minus 2 to 2. It is not minus 2 to 2. It is greater than 2 or less than minus 2. Greater than 2 or less than minus 2. This is the condition. So you can write down on your own, right? Now this particular thing and this particular thing you can write down on your own, because just compare with this. You will get the answer, right? Now mod of x less than equals to 2. Mod of x less than equals to 2. Mod of x less than equals to 2. That means x should be between minus 2 to 2. Say yes or no. Mod of x is less than equals to 2. That means x would be 1, 0, minus 1, everything will work. So x should be between minus 2 to 2. Or in the mathematics, we solve it, right? How do we solve it? Basically, what method I tell is that you first solve this particular thing. What you are getting? X equals to 2 and minus 2. So you make a line, x equals to minus 2, x equals to 2. Then you put any point. Let's just say I put 3. Then you put in this inequality. 3 is greater than equals to 2. 3 is less than equals to 2. Not true. That means this particular condition will not come. Then you put any point here. This particular condition will come. Then you put any point here. This particular condition will not come. So basically you solve the inequality taking the equal sign. Then you get the two values. You make these two values in this manner, and then put the example 3, then put the example 0, then put the example minus 3. Which condition is satisfied? This condition is satisfied. That means x will be between minus 2 to 2. But equal sign is also there. So equal sign will also be there. There you go. How will you write down the answer? Here we needed the equal sign, but here we did not need the equal sign. There you go. This is the answer, right? And if I need to think, how will I think? Fx of 2 will tell me minus fx of minus 2. So here what it has done? Less than 2, including the 2, but it has killed the minus 2 as well. Probability at minus 2 also it has killed. So what I will do? Probability at x equals to minus 2 I will add up. Okay, so these are the answers. These are all the answers. Is that clear to you? It was a good question. Not a simple question. I will not say very simple question, but we have seen the concept. Roughly around 1 hour we have spent only on this concept, because of what I feel is that from CDF, PDF, this is the only concept which they haven't asked. Okay, till this point they did not ask. And usually they also know that people will remember this particular thing. But can we write down this particular thing as well? So that's why they can ask this particular question. Okay, now solve this question. Do it on your own. Okay, do it on your own. Options are also mentioned. You need to tick one of the option. So solve it. Try solving it on your own. A random variable x is called symmetric about 0 if this is the condition. If this is the condition, then they are saying that random variable x will be symmetric. Now fx of x is CDF of x where x is symmetric about 0. So your random variable x is symmetric about 0, that means this condition is satisfied. In your case, this condition is satisfied. Now you need to find out probability of a mode of x should be less than equals to x. First question, second question, third question, do it on your own. Have some patience, try it on your own. Okay, I will take a break and then I will come back. You try doing it on your own. Yeah, welcome back. So did you try this question? So how would you start this question if this question is coming in the examination and let's just say only first one is coming? So would you analyze the condition first or would you solve the question first? You will try solving the question first, no? We can analyze the condition as well. But first intuition will say that, sir, I should go on to this particular expression. And then I will say that how I can use this particular condition, right? So I will, in the examination, I will start from here. So probability of a random variable mode of x taking value less than x. So I can write it down. This inequality we have already solved, right? We have already seen this inequality. So an equal sign is also there. So this is our desirable condition, right? All good, all fine. How I can write it down? I can write it down in this manner. Here I need the equal sign, so no issue. But here I don't need the equal sign, so there is an issue. So there is an issue, so I will put negative sign. Or how I can write it down? Fx of x minus fx of minus x. What does that mean? That means that I have killed the minus x as well, but you need minus x. What does that mean? That means you need to add the probability at minus x. This is what we have done. Is that clear to you? So this should be my answer. But none of the option is matching, right? None of the option is matching. You need to find out something to kill these two. I need to kill these two, right? This is the condition. In the options everywhere, fx of x is given. So I need to kill fx of minus x. Probability of x equals to minus x. This I need to kill. And how did I write it down? This should be clear to you. Say yes or no. Surely it is clear to you, right? Or you could have find out in this way as well, that probability of x equals to minus x would be given as fx of minus x minus fx of minus x minus. So from here fx of minus x you would have put in this particular expression, you would get fx of minus x and then this would become plus. So this you should be comfortable now. Now let's analyze the condition. From the condition, let's see what do we get. Is equals to right. This is the condition given. So here I can write it down in this manner. X less than small x. Say yes or no. Is equals to probability of x less than equals to minus x. But what do I want? I actually want equal sign here, so that I could convert it to our CDF. So I want a equal sign here. So basically, if I have written down this particular thing, that means what I have done? If I have written down this particular thing, that means 1 minus probability of x taking value less than equals to x. That means I am considering every value greater than x. What I am doing, I am considering every value greater than x, not including the x, but actually I need to include the x as well. So what I need to do here, I need to add the probability. Say yes or no. Are you able to understand this point? What I have done here? Are you able to understand what I have done here? Probability of x greater than equals to x. That means you need x as well and you need all these things as well. So what I have done, 1 minus probability of x less than equals to x. That means now this x is also killed. Since it is killed, I need to add it up. So probability of x taking value small x. Why I am doing so? I am doing so. Why is that so? Why I am doing so? So that now I can write it down as fx of x plus probability of x equals to x is equals to fx of minus x. So from here what you are getting, that your probability of x equals to x is coming out to be fx of minus x plus fx of x minus 1. There you go. This is something that you are getting, and this will answer your third question. There you go. Now from this expression, can you let me know what will be the probability of x equals to minus x? So basically, in place of x, you need to put minus x. So this will become plus x, this will become minus x. So basically from here, what did you get to know? That probability of a random variable x taking the value minus x and random variable x taking the value plus x both are same. So this also we got to know. And why I calculated the probability at x equals to minus x? Why did I calculate this? Because here I need this. So let's get back to our first question. Let's get back to our first question. This answers our third question. Third question have been already answered. Let's get back to our first question. In the first question where we were, just 1 second guys. Yeah. So this was, here I was already there, fx of x minus fx of minus x plus probability of x equals to minus x. This was easy to write down, right? Now what I can do, I can replace the probability of x equals to minus x here. How I can replace it? Fx of x, fx of minus x plus probability of x equals to minus x, that is given as fx of x plus fx of minus x minus 1. So this and this is getting cancelled. What is the answer you are getting? 2 fx of x minus 1. There you go. This is the answer. 2 fx of x minus 1. What about this one? Try solving it on your own. Surely you will be able to solve. 101% you will be able to solve. Probability of a random variable x taking value greater than x. There is no equal sign. What does that mean? X greater than x. If you solve it, you will get two answers. This region will come and this region will come. That means x can take value greater than small x or x can take value lesser than minus x. Is that clear to you? How will you write down this particular thing? Can I write it down in this manner? 1 minus probability of x less than equals to x. Surely I can write down, right? X greater than small x. Basically, this is what you need. Excluding the x. So what I have done? 1 minus everything. So this is what you are getting. Plus, if I write it down in this manner, that means what I am doing? I am needlessly including the minus x. That means now I need to subtract the probability at minus x. Is that clear to you? Are you able to understand this particular point? Here what I need to do, for defining the CDF, I need to add a equal sign. If I need to add a equal sign, what I need to do? If I need to add a equal sign, that means I am including the probability at x equals to minus x. But this is what you don't need. You don't need the probability at x equals to minus x. That means you need to subtract it, right? So what you are getting? 1 minus fx of x plus fx of minus x minus probability of x equals to minus x. What is the answer you are getting? Fx of x then minus fx of minus x, and this would become plus. Are you able to understand this point? So what will happen? This and this is getting cancelled. The answer you are getting is 2 minus 2 fx of x, 2 into 1 minus fx of x. This is the answer you are getting. There you go. 2 into 1 minus fx of x. 2 into 1 minus fx of x. So CAD, these were the answer. A very good question which will clear your fundamental concept, and these kind of question could be coming in your examination. Are you able to understand this point? Right? So this is how this condition was given. First I tried to solve the problem, then I got to know that I am not going anywhere. Then I utilized the condition. From the condition I got these two expressions. One was the answer of third question. Then I utilized this condition to get the other answer. I know that this is how I can write it down. Here I wrote it down, and from here I just put the condition and got the answer. So better than like, don't depend much on the method. Which method I am talking about? This particular method that we learn here. Don't depend much on that. you should be having the concept as well, because if you depend too much on the method, then it will not work. You should be having the concept. Like here directly I was able to think mod of x greater than x, that means I need greater than x less than minus x. If you need greater than x, that means 1 minus less than x including the x. And here to define the CDF I need fx of minus x. To define the CDF I need the equal sign here. That means now I need to kill the probability at x equals to minus x. That means I need to subtract the probability at x equals to minus x. So I subtracted that, then I was having the expression, I got the answer. Is that clear to you? Very easy, very straightforward, right? So this was the answer. Okay, so these kind of questions are good. Not many people would be able to solve, but we have understood it in a very good manner. So we will be able to solve this kind of problems if these are coming in our examination. Well and good. Now let's end this lecture here, because it's been roughly around 3 hours. So we are ending this particular lecture here. Now for the next 1 hour, roughly around 1 hour, we are going to study mathematics only. In between we will solve some problem of random variable as well, but mostly we will be studying probability. Okay, so in mathematics what we are going to study now, conditional probability we are going to see, which you might be already knowing, so you can watch it in a quick manner. Along with that we are going to see integral calculus, so which is a topic of mathematics only, which is a topic of calculus only. Integral calculus also we are going to see. So for next 1 hour it will be mathematics. In between we will solve some problem as well, like this particular question we are going to solve. This is based on PDF only, sorry, this is based on CDF or PDF, whatever it is. Then this particular question also we will solve. So this is mathematics, sorry, this is your random variable random process, but this is conditional probability, this is purely mathematics. So we will study mathematics, in between we will solve some problem as well. Okay, so don't ignore this part. The bottom line is don't ignore this mathematics part. So first we will see conditional probability, then in between we will see the Bayes theorem as well, and then we will study about integral calculus, and then we will start 2-dimension random variable. So as of now we were defining only one random variable, no, x. Now what if 2 random variables are defined together, x as well and y as well? 2 random variables are defined together. So now after that what we are going to see, 2-dimensional random variable. So let's end this video here. Now for the next 1 hour we are going to study mathematics. Okay, but don't ignore that part. Even if you have studied mathematics, watch that particular part in a quick manner. Okay then, yeah. So let me end this video here. Let's meet in the next video. Thank you very much.